Hello there, and welcome back to the Sleep Science. You've just stepped into that twilight space where your body is heavy, your eyelids are staging a protest against consciousness, and your mind floats in a slow river of imagination. Tonight, that river carries you not into a dream of your own past, but into the deepest, most ancient memory the universe itself still holds. Imagine light that has been travelling for over 13 billion years, longer than Earth has had oceans, longer than any mountain has stood, and tonight you're invited to catch it with your own eyes, as if it had been waiting just for you. You probably won't survive this trip in the literal sense. If you actually tried to stand naked in that primeval darkness, you'd be a popsicle of hydrogen molecules, but since this is sleepy science, you're allowed to hover safely, blanket-wrapped, like a ghost hitching a ride on photons. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. I love reading the little roll call of sleepy travellers, so go ahead and post your location and your local time in the comments. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You drift at first into silence, and that silence is deceptive. When astronomers speak of the cosmic curtain rising, they aren't being poetic, it's literal. For hundreds of millions of years after the Big Bang, the universe was like a sealed theatre, filled with fog so thick that light couldn't escape. Imagine being trapped in a stadium where the smoke machines went haywire. You wouldn't see the audience, just a choking, endless mist. That was the early cosmos, and you hover there, floating above an infinite arena, wondering how anyone could possibly peek behind this haze. Enter the James Webb Space Telescope. It's humanity's ultimate backstage pass. A glittering eye of gold perched a million miles from Earth, colder than Pluto and steadier than any camera ever built. Its mission, to peel away the fog of time and hand you the very first photons that dared to slip through. The moment you see them, it's not like a spotlight turning on. It's more like the slow unfurling of an old photograph in a chemical bath. Galaxies coalesce out of nothingness. Starlight sharpens. The black velvet around you suddenly has texture, as if someone embroidered jewels directly into space. And here's the twist, those jewels don't look the way textbooks said they would. They're too many, too bright, too organised for such a young universe. Historians still argue whether this moment in science ranks alongside Galileo first pointing his telescope at the moon, or whether it belongs in a category all its own, because what you're experiencing is not just discovery, it's contradiction. The universe has the audacity to look older than it should, and you can almost hear the collective groan of cosmologists who now need to rewrite their lectures. As you float closer, you notice one particularly bright smudge, just a faint reddish spark, stretched thin by billions of light years. This smudge formed only 300 million years after the Big Bang, which sounds like a long wait until you realise that in cosmic terms, it's basically the universe's first baby photo. If the cosmos were a person, you're looking at it while it's still in the maternity ward, screaming for milk and warmth. Yet somehow this infant galaxy already glitters with stars, some huge, some small, arranged in ways that shouldn't be possible. And here comes your first quirky tidbit. In ancient Mesopotamia, priests believed that the stars were tiny holes in a cosmic dome letting divine light shine through. Tonight, Webb makes that image weirdly literal. The galaxies do look like punctures, like someone poked the canvas of reality and let fire seep through from another dimension. Of course, we now know those smudges are titanic furnaces, each with billions of stars, but you can't help chuckling at the coincidence that the oldest stargazers weren't completely off. You drift further, and the thought occurs, the light touching your eyes left its home long before Earth existed, long before the sun ignited. That's not just poetic fluff, it's a mathematical fact. These photons travelled 13.5 billion years, dodging cosmic dust, slipping past galaxies, and stretching thin like taffy under the relentless pull of expansion. And after all that, they slam directly into Webb's golden mirrors and, seconds later, into your imagination. It's like receiving a postcard from someone who mailed it before humans evolved lungs. But here's the cheeky part. If the universe were truly as cooperative as textbooks once implied, you wouldn't be shocked right now. You'd be nodding politely saying, "Ah yes, galaxies forming right on schedule, how predictable." Instead, you're caught in a cosmic plot twist. The curtain rises, and the play refuses to follow its script. Scientists thought the first galaxies would be faint, disorganized, struggling to ignite stars out of primordial hydrogen. Instead, they look vibrant and crowded, as though someone skipped half the rehearsal. Imagine expecting to walk into a kindergarten classroom only to find the kids writing doctoral theses in quantum mechanics. You'd raise an eyebrow, right? That's essentially what Webb just did to cosmology, and the humour isn't lost on you. NASA built a $10 billion telescope to confirm theories, and the universe said, "Nice try, nerds, but here's a curveball." You glide on, feeling a sense of vertigo. These aren't just distant galaxies, they're miniatures, held up to your own fleeting human span. You live maybe 80 years, if you're lucky. These galaxies glow across spans longer than you can pronounce. Yet even they too are temporary. They'll collide, merge or fade, and there you are, a temporary creature, whispering to yourself, "I was here to see the first light." It's humbling but also comforting, because if the cosmos itself can start messy, out of order, and still grow into what we see tonight, then maybe your own life doesn't need to follow the perfect script either. Meanwhile, in the background, a more practical voice reminds you of another fact. When Galileo unveiled his telescope in 1609, the Catholic Church literally tried to sentence him for describing moons around Jupiter. Back then, society wasn't ready for reality. Tonight, staring at Webb's first images, you wonder, are we ready? Because what you're seeing threatens not just equations, but the cozy idea that the universe is simple and knowable. Historians still argue whether humanity truly accepts paradigm shifts quickly, or whether we just pretend to while secretly resisting. Looking at these early galaxies, you get the sense that resistance is futile. Light this ancient doesn't care about your comfort zone, it just keeps shining. You take one last look at that reddish smudge, aware that what you're seeing is both fragile and indestructible. Fragile because it represents a specific instant in cosmic history that can never be repeated. Indestructible because those photons already made their journey. They will forever have existed, forever have left their home. As your eyes grow heavier, the starlight begins to blur. You can almost hear the quiet hum of Webb itself, floating far from Earth, shielded from the sun, colder than any winter you've ever known. Tirelessly staring into forever on your behalf. You realise you've only just cracked open the curtain. Behind it, entire acts of the play still wait, each more bewildering than the last. And so you drift on deeper into the golden eye's vision, toward brighter smudges and stranger shapes. Your journey is only beginning, and the curtain, once raised, cannot be lowered again. You float onward through that velvet black ocean, and suddenly your eyes catch a golden gleam. Not starlight this time, but the polished reflection of a machine unlike any you've ever seen. The James Webb Space Telescope hangs in the void like a cosmic chandelier, its hexagonal mirrors glinting faintly with the echo of suns. You feel almost shy approaching it, as though you're sneaking into the control booth of the universe's largest theatre. From this close, the geometry makes sense. 18 hexagons tiled like honeycomb, a design borrowed straight from the bees. And like bees, those mirrors are relentless workers, capturing every stray photon they can. You realise the whole telescope looks more like jewellery than science, a necklace the cosmos forgot to wear, now dangling momently in the darkness. It's hard not to compare Webb with its ancestor, the Hubble Space Telescope. Hubble was magnificent, no doubt. It gave us those iconic images of swirling galaxies that wallpapered classrooms and laptops for decades. But poor Hubble had one embarrassing childhood story. When it launched in 1990, its main mirror was ground ever so slightly wrong, leaving all its images fuzzy until astronauts fixed it. It's as if humanity spent billions to send a telescope into orbit with smudged glasses. Webb, on the other hand, needed no repair crew. It unfolded itself like origami a million miles from Earth, each hinge and latch clicking into place with the precision of a Swiss watch. You hover near the giant sunshield, a structure the size of a tennis court. Thin, silvery layers stretch below the mirrors, blocking heat from the sun and Earth. Without this sunscreen, the telescope would fry. It makes you grin. Humans complain about reapplying SPF on a beach day, but here's a spacecraft lathered up in 5 layers of reflective foil, because space is the harshest tanning bed in existence. And then there's the temperature. Webb operates at around minus 370 degrees Fahrenheit. That's colder than dry ice, colder than Antarctica in the dead of winter. At that temperature, metals shrink, lubricants freeze, and electronics threaten to misbehave. Yet Webb survives by sheer engineering poetry. Its instruments are so cold they make your refrigerator look like a sauna. You remember a mainstream historical fact: in 1672, Isaac Newton presented his first reflecting telescope to the Royal Society, proudly showing how mirrors could focus light without the colour distortions of lenses. That little tube was barely the length of your arm, and yet it opened the skies in ways no one had imagined. Now, 3.5 centuries later, you're floating beside the ultimate descendant of Newton's mirror, a golden flower that peers not just at stars but at time itself. If Newton could see this, he'd probably spill his apple cider in disbelief. But here's the quirky tidbit that makes you chuckle. Webb's mirror is coated in real gold, though not enough to make a rapper jealous. The layer is only a few hundred atoms thick, so thin you couldn't even see it if it weren't spread across such a wide surface. In total, the telescope uses about the same amount of gold as a wedding ring. Imagine explaining that to aliens. Yes, we spent $10 billion to launch a giant piece of jewellery into space. You almost want to call it the universe's engagement ring. The mirrors themselves bend light into Webb's scientific instruments, which detect infrared wavelengths. And this is the secret sauce. Infrared lets you see through dust clouds that block ordinary light. It's the cosmic equivalent of night vision goggles. To your eyes, the universe is a foggy window smeared with fingerprints. To Webb, it's suddenly transparent. You think about how fragile the unfolding process was. For nearly a month after launch, engineers on Earth held their breath as Webb carefully unfolded like a mechanical lotus. Each step, deploying the sun shield, adjusting the mirrors, cooling the instruments, could have failed catastrophically. Imagine assembling a tent blindfolded in the middle of a hurricane. Except the tent costs $10 billion and you can't touch it once it's out there. That's what NASA pulled off. You almost clap, floating in silence, just to honour the absurd courage of it. Historians still argue whether this telescope marks the pinnacle of space engineering or simply a stepping stone toward even more ambitious projects. Some dream of future instruments with mirrors kilometres wide, or fleets of smaller telescopes flying in formation like synchronised swimmers. You picture it, a whole orchestra of golden eyes tuning themselves to the symphony of the cosmos. Webb, in that vision, is just the opening solo. Your gaze drifts across the segmented surface. Each hexagon can adjust independently by minuscule amounts, fractions of a hair's width, to keep the focus razor sharp. It reminds you of synchronized dancers keeping perfect rhythm. If even one tile misbehaved, the whole image would blur. Yet here they are, moving in harmony like the universe's most patient ballerinas, and there's something almost human about it. Webb is, after all, not alive. It has no feelings, no awareness. And yet, as you watch the golden mirrors tilt and breathe, you feel like you're in the presence of a giant mechanical eye with its own quiet determination. You find yourself whispering encouragement. You're doing great, buddy. Keep staring, girl. The telescope doesn't respond, of course, but you notice how small Earth looks behind it, just a pale dot hidden beyond the sunshield. That's where your species lives, where every story you've ever heard unfolded, where Newton scribbled equations and Galileo squinted at Jupiter's moons. And here you are, riding piggyback on humanity's farthest seeing machine, looking not at Earth but at the beginning of everything. It strikes you that Webb is not just a tool, it's a kind of time machine. It doesn't move through time, instead, it waits patiently for ancient light to arrive. Every photon it catches is a relic, a messenger from billions of years ago, and you, lucky passenger, get to witness those messages firsthand. To keep yourself awake, you make a little joke. Webb is basically the universe's ultimate Instagram filter. It makes the oldest galaxies look good, smoothing out cosmic blemishes and highlighting the glow. Somewhere, you imagine, an alien influencer is jealous. Yet the reality is even more profound. By staring with such sensitivity, Webb isn't just painting pretty pictures, it's testing physics itself. Every surprising galaxy, every unexpected colour, is a puzzle piece that either fits snugly into our models or forces us to redraw the picture. And tonight you feel the edges of that puzzle shifting under your fingertips. You let your mind wander to the people who built it. Thousands of scientists, engineers, technicians, entire careers spent ensuring one screw tightened correctly, one circuit insulated properly. Generations who may never see the end of Webb's discoveries, but who trusted the future enough to send this golden eye beyond the reach of repair. You think about that gamble. No astronauts can fix it. no mechanic can tow it back. Once launched, it either worked, or it became the most expensive piece of space junk ever made. The stakes were cosmic, and so you breathe slowly, appreciating the miracle that it did work, that it floats here now, glittering, calm, focused. The hum of its instruments seems almost like a lullaby in the background of your drifting thoughts. Before long, you're less focused on the machine itself and more on what it reveals. Those mirrors are not looking at you. They are looking past you, far deeper, back into time's earliest whispers. You can almost feel the photons sliding past you into Webb's detectors, as if you're standing beside a friend who can see through walls. And so you turn your eyes forward again, leaving the golden telescope to its vigil. The curtain is drawn higher now, the smudges sharper, the surprises stacking. The tool has been admired, the eye understood, and now it's time to see what it sees. The golden mirrors fade behind you, and what fills your vision now is the first real treasure Webb has handed over. A field of galaxies, each one a surprise, each one brighter and bolder than you expected. For years, textbooks told you the early universe should be quiet and dim, a foggy nursery where galaxies stumbled like toddlers learning to walk, and yet, here they are, glowing fiercely, practically shouting across the void. You hover, stunned, as if the curtains of the theatre have been pulled back and, instead of a rehearsal, the cast is already mid-opera, costumes perfect, voices booming. You almost want to whisper, excuse me, weren't you supposed to still be figuring out the script? The first light Webb delivered to the public, remember that image plastered across every news site, was a patch of sky so small you could cover it with a grain of sand held at arm's length. That tiny speck, magnified by Webb, revealed thousands of galaxies layered on top of one another like jewels spilled across velvet. It's dizzying to realize if such richness hides in a dot, then the whole universe must be an overflowing treasure chest. You pause and let your mind stretch. Each of those galaxies contains hundreds of billions of stars. Each of those stars might host planets, some perhaps with oceans, skies, or even beings wondering if they're alone. Suddenly you feel like someone who opened a junk drawer expecting a few old batteries and instead discovered the crown jewels. And here's the kicker. Many of these galaxies shouldn't exist yet, at least not according to the model scientists carried proudly into the Webb era. Cosmologists predicted faint smudges, tentative sparks just beginning their climb. Instead, Webb shows galaxies fully ablaze only a few 100 million years after the Big Bang. It's as though someone pressed fast forward on cosmic evolution. Historians still argue whether this is truly a revolution or just a refinement, a matter of tweaking models versus tossing them out the window. Some say it's like finding a wrinkle in the fabric of physics. Others whisper it might be a tear. Either way, you can sense the buzzing arguments happening in conference halls, PowerPoint slides flashing, equations scribbled in panic, coffee consumed like oxygen. You drift closer to one of the galaxies, and it's hard not to compare it to a city seen from an airplane at night. Streets of starlight weave into clusters, bright neighbourhoods glow, and faint outskirts sprawl. It feels alive, pulsing, radiant. And you realise these aren't just distant points of interest. They're ancestors of the galaxies we see today. Perhaps this one will, after billions of years, grow into something like the Milky Way. Perhaps, just perhaps, your atoms were once forged in a star not unlike the ones you're seeing right now, blazing in this infant city of light. To ground yourself, Joe, you remember a historical fact. In 1924, Edwin Hubble discovered that the fuzzy nebulae astronomers had catalogued were actually separate galaxies far beyond the Milky Way. That was the moment humanity realised the universe was vastly bigger than anyone imagined. Now, nearly a century later, Webb has staged a sequel. Not just that there are countless galaxies, but that they appeared shockingly early. You imagine Hubble himself shaking his head in disbelief, muttering, "You've got to be kidding me." And here comes your quirky tidbit. One of Webb's early deep-field images caught the faint glow of a galaxy nicknamed the Sparkler because of the way tiny globular clusters glittered around it, like someone had tossed cosmic confetti. Astronomers got giddy, the way kids get over fireworks, zooming in on those specks to study ancient star clusters. You grin at thought. Humanity spends billions on fireworks displays every year, yet the universe has been putting on its own pyrotechnics since before Earth formed. Of course, the sheer brightness of these galaxies leads to jokes among astronomers. Some wondered aloud if Webb had accidentally stumbled on the universe's flashlight aisle. Others teased that maybe aliens held an intergalactic rave 300 million years after the Big Bang and forgot to turn the lights off. You chuckle with them because if science can't be a little ridiculous, what's the point? But beneath the humour, a real puzzle gnaws. How could galaxies this large and bright form so fast? Stars require time to condense from hydrogen clouds, to fuse helium, to cluster together into disks. By every prior calculation, they shouldn't have had enough time, and yet Webb's images scream otherwise. It reminds you of walking into a bakery 10 minutes after it opened, expecting empty trays, only to find shelves groaning under loaves, cakes, pastries, all perfectly frosted. You'd blink and ask, who did all this? How? Did someone cheat and start baking yesterday? That's exactly the cosmic question now rattling astrophysics. Did the universe start forming stars sooner than we thought? Or is something else entirely at play? The scholarly debates swirl. Some suggest dark matter may have condensed more efficiently, pulling galaxies together quickly. Others hint that maybe our understanding of star formation is flawed, that stars can grow faster under the right conditions. A few fringe voices even wonder whether the cosmic expansion rate itself needs revision. The beauty is, nobody knows for sure yet. You're drifting in the middle of an open mystery, watching theories wobble like unsteady Jenga towers. Your eyes return to the faint red smears scattered across the field. Red, because the universe has stretched their light during its expansion. This redshift is how astronomers measure distance and age. The redder the galaxy, the farther back in time you're seeing. Some of Webb's finds boast record-breaking redshifts, pushing your gaze closer and closer to the dawn of time. And still, the colours are hauntingly beautiful. What you see isn't just dull crimson, it's layered, glowing, a tapestry of subtle hues. It's like staring at the embers of an ancient fire that somehow never went out. You catch yourself breathing slowly, as though your lungs are afraid of disturbing the light. To lighten the moment, another joke flits through your mind. All this talk of first light, and yet if humans had been around back then, they'd probably have slept through it, just like they sleep through meteor showers now. You imagine some cosmic alarm clock ringing 13.5 billion years ago, and everyone hitting snooze, yet here you are, awake, watching, and in a way you realise you're fulfilling the destiny of that light. Photons launched on their journey when the universe was still an infant now finally meet an observer. You. They've been homeless wanderers for eons, and tonight, in your mind, they find their resting place. It's humbling, but also thrilling. Because if the first surprise of Webb is that galaxies came early and bright, the second surprise is more personal, that you, a tiny being on a tiny planet, are capable of witnessing and pondering it. Light is not just physics, it's intimacy. You and the cosmos are sharing a secret. As your thoughts soften, you imagine drifting between those galaxies, weaving among their stars, brushing against their dust. Each one hums with the energy, each one promises new questions, and each one whispers the same thing. The universe is stranger and more generous than you expected, and so you let the field of galaxies surround you, their brightness pressing against your eyelids like dreamlight. The first act of Webb's story is already shocking enough, but you can sense the next act will only deepen the astonishment. You drift onward, ready to confront the small giants and the puzzles of speed that lie ahead. You drift deeper into the patch of sky Webb has unfolded for you, and soon your eyes pick out galaxies that seem wrong. Not wrong in the sense of broken, but wrong in scale. They look small, almost fragile, like smudges you could erase with the swipe of a fingertip. But then the data whispers the truth. These tiny things burn with the fury of giants. Their starlight outshines expectations, as if someone fit the energy of a metropolis into the footprint of a village. You pause, baffled, because this doesn't match the script you were given in science class. Small galaxies, according to the old narrative, should be timid, flickering, barely managing to light a few stars. Instead, Webb shows you little dynamos blazing like cosmic furnaces, compact yet ferocious. Imagine a matchbox that roars hotter than a bonfire. That's what you're floating beside. Scientists call them dwarf galaxies, but the word doesn't feel righter when you're staring at their glow. They might be small in size, yet their brightness screams confidence. You can't help but joke to yourself. It's like meeting someone 5 feet tall who insists on dunking basketballs just to prove a point. The universe apparently has a sense of humour about scale. You hover closer, letting your mind wrap around the paradox. How could something so small sustain such furious star formation? Did they cram more gas into their compact cores? Did their stars form with reckless abandon, burning themselves out faster? Whatever the answer, the galaxies seem to lean toward you with a smug grin, saying, "Yeah, we're small, but we party harder." The scholarly debates flare. Some astrophysicists argue that these galaxies represent the building blocks of larger ones, tiny embers that later merge to create the grand spirals and ellipticals we see nearby. Others counter that these dwarfs might be more self-sufficient, survivors that refuse to be swallowed. Still others wonder if Webb is forcing us to reconsider the efficiency of early star formation altogether. Historians still argue whether science progresses by gentle refinements or by shocking upheavals, but in this case you feel the upheaval under your very feet. And then, a mainstream historical fact rises to mind. In the 1920s, astronomer Harlow Shapley debated whether the Milky Way was the entire universe, or just one galaxy among many. He insisted the Milky Way was dominant, while Edwin Hubble later showed otherwise. Tonight, you witness a parallel tension. Do these little galaxies matter only as ingredients for something larger, or are they independent players with their own long destinies? The echoes of past debates ripple right into your present. A quirky tidbit makes you smile. In one Webb image, a tiny galaxy looks oddly like a cosmic tadpole, with a bright head and a wispy tail. Astronomers, never ones to resist whimsy, actually call it a tadpole galaxy. And you can't help picturing the early universe as a pond, filled with glowing tadpoles wriggling into starlight. Somewhere, surely, a cosmic frog is chuckling, but beneath the whimsy is a deeper tension. If these tiny galaxies shine so fiercely, does that mean the early universe was more efficient than expected at creating stars? Or could it be that our models underestimated how quickly matter clumped together under gravity? One camp of scientists suggests that dark matter halos, the invisible cocoons thought to cradle galaxies, were denser and more hospitable than simulations predicted. Another camp argues maybe we've missed a key step in how gas cools and collapses into stars. And of course, the fringe voices whisper that perhaps the laws of physics themselves behave differently under such extreme conditions. You, adrift among these fiery dwarfs, feel the tug of that mystery. It's as though the universe is whispering, "Don't be so sure you know me. I still have tricks tucked away in my smallest corners." To keep yourself grounded, you compare it to everyday life. You've met people who look unassuming but carry astonishing energy. Grandparents who still outdance everyone at weddings, quiet students who suddenly deliver brilliant speeches, tiny dogs with bark loud enough to rattle windows. These galaxies feel like the universe's version of that archetype. Never underestimate the little ones. Your eyes linger on one dwarf galaxy so bright it looks like a cosmic spotlight. Its light has travelled for over 13 billion years, carrying the fingerprint of furious starbirths. If you could listen closely, you imagine it would sound like the crackle of a roaring fire. You almost press your hands toward it, as though to warm yourself by its ancient blaze. Then a wry thought slips in. Humans argue endlessly about tiny homes and minimalist lifestyles, while the universe has been showing off tiny homes of stars since the dawn of time. And unlike human minimalism, which usually comes with IKEA instructions and lots of frustration, these galaxies figured out compact living with elegance. The scholarly debates you overhear grow louder. One scientist insists these bright dwarfs are rare jewels. Lucky finds are magnified by the Webb's sharpness. Another counters that they might be the rule rather than the exception, that the early universe was teeming with such fireflies, and we just lack the eyes to see them until now. The argument makes you smile. It feels like listening to chefs argue over whether a secret recipe uses salt or sugar. Either way, the dish exists and it's delicious. You think again of history. When Galileo aimed his telescope at the Milky Way in 1610, he realised it wasn't a smooth band of light but countless individual stars. That revelation alone cracked open humanity's sense of scale. Now, with Webb, you're seeing another layer peeled away. Not just that galaxies are numerous, but that even the smallest ones can punch far above their weight. You drift farther into the cluster, surrounded by these glowing miniatures. They sparkle like lanterns in the dark, each one a paradox of fragility and power. You feel humbled, reminded that size alone isn't destiny, that brightness can emerge from the unlikeliest places. And here comes joke number 3. You imagine an early universe talent show where the giant galaxies lumber on stage, confident in their mass, only to be outshone by a tiny dwarf belting out a starburst solo that brings the house down. The crowd goes wild and the giants sulk in the corner. Cosmic karaoke at its finest, the laughter fades into awe. Because beyond the jokes, what lingers is the sense of how much you don't know. The tiny giants are teachers, hinting that the universe is less predictable, more chaotic, and far more creative than the neat charts and models suggest. You close your eyes for a moment, letting their light soak through your imagination. They don't ask for explanations, they just burn defiantly across billions of years. And as you drift onward, deeper into the field of galaxies, you carry their lesson with you. Never underestimate the quiet, the small, the overlooked. Sometimes the brightest revelations come in the tiniest packages. You leave the tiny firecracker galaxies behind, still blinking from their unexpected brightness, and your eyes settle on something stranger. The sense that everything here is moving too fast. Not the galaxies physically rushing past you, though they do race away with the universe's expansion, but their very development. They look too grown, too mature, too polished for their age. You feel as though you've stumbled into a classroom of toddlers who are already solving algebra. Someone skipped steps. Someone forgot to tell these galaxies they were supposed to crawl before they sprinted. And here you are, trying to keep up, while the cosmos laughs quietly at your confusion. The data from Webb insists on it. Galaxies only a few 100 million years old already look like seasoned veterans. They've birthed countless stars, organized into complex shapes, and produced elements heavier than hydrogen and helium. They're like cosmic teenagers who went from diapers to driving licenses overnight. You shake your head, wondering if the universe has a secret stash of espresso shots it hands out in the early morning of time. Scientists call this puzzle the too big, too early problem. Galaxies shouldn't have had enough time to collect so much mass, and yet Webb reveals them, smug and glowing. Imagine showing up at a marathon expecting to see runners warming up and instead finding a few already waving from the finish line. It makes you laugh and groan at once. The scholarly debates around this are fierce. Some researchers argue maybe our models underestimated how fast gas clouds can collapse into stars under early conditions. Others suggest dark matter, halos may have been denser, pulling matter together with a stronger gravitational hug. And then there are the more radical whispers. Maybe the rate of cosmic expansion, what we call the Hubble constant, needs rethinking. Historians still argue whether this will turn out to be a small adjustment, or the opening of a new physics chapter. You recall a mainstream historical fact that suddenly feels relevant. In mid-15, Albert Einstein introduced his general theory of relativity, revolutionizing how we think about space and time, but within a year he added a cosmological constant to keep the universe static, because he couldn't imagine it expanding. Later, Edwin Hubble's discovery of expansion made Einstein admit it was his biggest blunder. Now, as you stare at Webb's galaxies, you wonder if today's cosmologists are walking into their own blunder, underestimating just how tricky the cosmos can be. A quirky tidbit bubbles up. One of Webb's observations caught a galaxy nicknamed Glass Z13, which may have formed just 300 million years after the Big Bang. Astronomers couldn't resist the playful naming, part acronym, part glass slipper. You grin at the thought of Cinderella galaxies rushing to the cosmic ball, except in this version they showed up before the castle was even built. The speed is unsettling but also exhilarating. If galaxies formed earlier and faster than expected, then the universe may be more efficient, more restless, as your equation suggested. It's like meeting a friend who swears they're terrible at cooking, then serving you a 5-course dinner 2 hours later. You're impressed, suspicious, and very hungry for answers. To steady your thoughts, you consider the possibility of error. Could Webb's instruments be fooling us somehow? After all, redshifts can be tricky to measure, and early claims always need careful checking. Maybe these galaxies aren't quite as old as they look. Maybe they're imposters, nearer objects masquerading as ancient ones. It wouldn't be the first time the cosmos played a prank. You imagine galaxies wearing fake moustaches, sneaking into the early universe club, but the evidence keeps piling up, and the imposter theory looks weaker every day. More spectroscopic measurements confirm the shocking ages. The too fast galaxies are real, not cosmic frauds. And so, the puzzle sharpens. Either galaxies formed at lightning speed, or our cosmic timeline is missing chapters. You think of a metaphor close to home. Humans are always trying to speed things up. Fast food, high-speed internet, same-day shipping. Maybe the universe simply beat us to the punch. The first galaxies were the original overachievers, cranking out stars before it was trendy. And just like us, they may have burned out faster for their impatience. Still, the seriousness of the puzzle gnaws at you. If galaxies appear too soon, then what else might the universe be hiding? Did stars form from exotic physics we don't yet understand? Did dark matter play a more hands-on role than expected? Or, and here's the unsettling possibility, have we misread the entire rhythm of cosmic history? Historians still argue whether humanity ever truly grasps revolutions in real time. When Copernicus proposed the sun at the centre, many clung to the old Earth-centred view for decades. When Darwin wrote about evolution, the ripples of acceptance and resistance stretched across centuries. Tonight, drifting in Webb's field, you feel that same tension, a revolution half realised, still resisted by the comfort of old models. A light joke eases the tension. You imagine astrophysicists holding emergency therapy sessions. "Hi, my name is Dave, and I just found a galaxy that shouldn't exist." The group nods sympathetically, clutching coffee cups the size of small moons. If nothing else, Webb is boosting caffeine sales. But beneath the humour, you feel awe. The puzzle of speed isn't just about equations, it's about humility. You thought the universe would behave, follow the neat choreography humans sketched out on whiteboards. Instead, it sprints ahead, daring you to catch up. And in that chase, you glimpse the raw vitality of creation. You linger on one particularly luminous galaxy, its light stretched crimson by expansion. It feels ancient, defiant, a message in a bottle hurled across eons. You almost hear it whisper, "You think you know how fast I should grow? Watch me." And you shiver, not from cold, but from the thrill of being proven wrong. The quirky part of your brain can't resist another joke. If galaxies really matured this fast, then somewhere out there must be a cosmic grandmother galaxy, knitting spiral arms and baking star cookies while the rest are still crawling. The thought makes you laugh softly, though you know the truth is far stranger than knitting. As your eyelids grow heavier, you realise the puzzle of speed isn't something you'll solve tonight. But maybe that's the beauty. Mysteries this grand aren't meant to be tidied up in a single lecture or a single lifetime. They're invitations to keep looking, to keep wondering, to keep letting the cosmos outpace your expectations. And so you drift onward, leaving the too fast galaxies glowing behind you. Ahead, you sense an even stranger sight. Clusters where astronomers once expected emptiness. The universe is about to get crowded, and you're floating straight into the crowd. You drift further along Webb's golden gaze, expecting the blackness of space to spread out in calming silence. Instead, the view tightens, the way a subway platform feels at rush hour. Galaxies huddle together in a density that borders on claustrophobic, each one brushing shoulders with its neighbours, like commuters unwilling to make eye contact. You blink, because this isn't what you were promised. The early universe, scientists said, should be wide open, sparsely populated, still giving galaxies elbow room to grow. And yet Webb shows you clusters, crowds really, bustling together mere hundreds of millions of years after the Big Bang. You float above one of these clusters, and it looks like a cosmic downtown at night. Towers of galaxies pressed close, glowing windows of statues stacked one after another, their light overlapping until you can hardly tell where one ends and another begins. The crowd hums with energy. You imagine the gravitational conversations happening between them, tugs, pulls, whispers of attraction, as they dance around one another in a slow, inevitable embrace. The surprise is how soon this cosmic overcrowding begins. Scientists once thought galaxy clusters took billions of years to form. After all, gravity is slow and patient, like a gardener waiting for trees to grow. But Webb suggests otherwise. Even in the universe's toddler years, clusters were already sprouting, pulling galaxies together in massive knots. It's like finding an apartment complex fully rented out before the foundations have finished drying. Historians still argue whether Webb's images should be read as proof of early cluster formation, or whether gravitational lensing, where massive objects bend light, might be tricking us into seeing more structure than exists. The scholarly debates fill conference rooms. Some insist these are genuine baby clusters, others say they're mirages stitched together by warped space-time. You hover between camps, watching both sides gesticulate with laser pointers. To ground yourself, you think of a mainstream historical fact. In the 1930s, Fritz Zwicky studied the Coma cluster of galaxies and noticed their motion didn't make sense unless invisible mass, what we now call dark matter, was holding them together. That was the birth of the dark matter concept, which still haunts physics like an unsolved riddle. And now, staring at these early clusters, you wonder, is dark matter once again the secret ingredient gluing the cosmos together faster than it should? A quirky tidbit cuts through your thoughts. Some of Webb's cluster images show galaxies stretched and warped into arcs, like taffy pulled too far. Astronomers call these Einstein rings, or gravitational lenses, where the light of background galaxies gets bent around a massive cluster in the foreground. You grin because the effect makes the universe look like it's wearing funky glasses, distorting reality with a stylish flair. You can almost hear the cosmos saying, "Check out my new frames, do they make me look mysterious?" The crowding, though, is no joke. Galaxies this close together are destined to interact, sometimes violently. Collisions, mergers, tidal distortions. This is not a polite cocktail party, but a mosh pit. Yet somehow, amid the chaos, structure emerges. Giant elliptical galaxies grow from repeated collisions, sprawling superclusters form, and the sheer web of the cosmos begins to take its shape. You can't resist a light joke. Somewhere in this galactic crowd, two galaxies are bumping into each other awkwardly, muttering, "Sorry, didn't see you there," while their stars scream across gravitational tides. The universe is full of these cosmic meet-cutes, except the dates last billions of years and usually end with the two merging permanently. Romance on a grand scale, the debates stretch wider. Some scientists argue that Webb's overcrowding hints at a universe far more efficient at building structure than models allow. Maybe gravity works differently at cosmic scales than Newton or Einstein described. Others suggest perhaps the distribution of matter after the Big Bang wasn't as smooth as the cosmic microwave background implied. Maybe clumps and wrinkles seeded clusters early. And of course, fringe thinkers throw in wilder options. Altered laws of physics, hidden forces, or even echoes from a pre-Big Bang universe. You hover, amused, imagining cosmologists with chalkboards scrawled edge to edge, equations spilling like graffiti. And someone finally saying, "So, what if space just really likes group projects?" It's strange, though, how this crowding shifts your perspective. You expected loneliness in the early universe, a scattering of faint embers. Instead, you see community. Galaxies huddled together, sharing gravity, swapping gas, igniting stars. The cosmos didn't waste time walling things off, it built neighborhoods. It's almost comforting in a way to think the universe has always been a social creature. You recall another historical parallel. In ancient Greece, the philosopher Democritus imagined that atoms clumped together to form worlds infinite in number. His ideas were dismissed as speculation, but now you watch galaxies clump together to form clusters, infinite in variety. The instinct to imagine crowding and clustering seems older than science itself. As you drift closer to one of the clusters, you notice something striking. The combined light of its galaxies glows brighter than the sum of its parts, a synergy born of proximity. You can almost hear it humming, like a choir warming up, each voice blending into something greater. The sensation is oddly musical, as though the universe were rehearsing harmonies long before humans invented instruments. And here's joke number 2. If galaxies and clusters really influence each other this much, then somewhere out there must be the equivalent of a nosy neighbour galaxy, leaning over the cosmic fence to borrow some star-forming gas. You imagine it showing up uninvited. "Hey, do you mind if I siphon off a bit of hydrogen? Promise I'll return it." But behind the humour awe builds. The clusters are proof that the universe doesn't like empty space. Left alone, matter finds company, gravity arranges gatherings, light fills the void. Even in the earliest chapters, loneliness was not the default, togetherness was. Still, you can't escape the puzzle. Why so soon? Why so crowded? Historians still argue whether Webb's images will force a full rewrite of cosmic history, or simply a tweaking of formation timelines. For now, the answer is suspended in uncertainty, like a question written across the stars but not yet translated. The quirky part of your brain offers a final image. The universe is a colossal dance floor, galaxies packed shoulder to shoulder, the DJ being gravity itself, spinning records that nobody can resist. And you laugh softly at the thought, because even at 13.5 billion years distance, the party hasn't stopped. You drift back, letting the glow of the crowded clusters fade slightly, leaving behind their warmth and noise. Ahead you sense a different mystery. Dust. Not the kind that clogs your shelves at home, but dust that defies explanation. Heavy elements appearing far earlier than they should. You turn your gaze toward that enigma, ready to breathe it in. You drift out of the crowded galactic neighborhoods, leaving their bright chatter behind, and soon the scene changes. The light around you softens, thickens, takes on a muted haze, as though the stars themselves are caught behind gauze curtains. At first you think your eyes are blurring, but no, it isn't your vision, it's dust, not the boring dust on your bookshelf that makes you sneeze, but cosmic dust, grains forged in the furnaces of dying stars drifting across the universe like ancient perfume. This is the shock Webb has uncovered. Heavy elements, carbon, oxygen, silicon, iron, appearing in the cosmos astonishingly early, just a few 100 million years after the Big Bang. According to old models, these elements should have needed far longer to accumulate. They are born when the stars burn, age and explode, scattering their innards across space. It's a recycling process that takes time, measured in stellar lifespans, and yet Webb's instruments are picking up dust and metals as though the universe had been on fast forward from the very beginning. You hover inside a cloud, particles drifting past like golden flecks in sunlight. Each grain is smaller than smoke, yet together they cloak galaxies in veils that ordinary telescopes can't penetrate. Only Webb's infrared vision slips through, peeling back the curtain to reveal what lies inside. Newborn stars cradled in dusty cocoons, planets perhaps already forming in embryonic swirls. The contradiction gnaws at you. How can dust exist so early? Did stars live fast and die young, exploding as supernovae mere millions of years after forming, seeding the cosmos with metals before anyone thought possible? Or does this mean some unknown process manufactures heavy elements without needing whole generations of stars? The question is unsettling because it suggests a universe more impatient, more reckless than the tidy narratives drawn in textbooks. A mainstream historical fact flickers in your memory. In 1957, scientists published the famous B2FH paper, named for Burbage, Fowler and Hoyle, which explained how stars forge elements inside their cores. That paper is often called the birth certificate of nucleosynthesis, the science of element making. Since then, we've believed heavy elements are the children of stars, but now, looking at this early dust, you wonder if that family tree is incomplete. Maybe there's another parent we haven't met. And then, a quirky tidbit makes you smirk. Ancient Egyptians used to believe dust storms were the breath of the god Set, chaotic and destructive. Tonight, floating inside cosmic dust, you almost sympathize with them. It does feel like the breath of something immense, whispering through space. You half expect a booming voice to complain that you've trespassed in its dusty living room. The scholarly debates rage hotter than any star. Some astrophysicists argue that the first stars, so-called population 3 stars, were monstrously large, hundreds of times the sun's mass. They might have lived short, furious lives, exploding quickly and scattering metals into space at a pace that explains the dust. Others push back, saying we've never directly observed such stars, and it's risky to lean on them as an explanation. Still others propose exotic processes. Perhaps black holes contribute, or unknown physics speeds up nucleosynthesis. Historians still argue whether Webb's data marks the end of old theories or merely a rough patch in our understanding. Meanwhile, you can't resist a light joke. Humans spend weekends dusting their homes, vacuuming corners, battling particles that never seem to vanish. Yet here you are, surrounded by dust that astronomers treat like treasure. You almost want to mail a note to NASA. Free cosmic dust available on my bookshelf. Please send $10 billion to retrieve it. The dust isn't just a nuisance or a puzzle, it's also beautiful. Infrared images reveal glowing filaments winding like smoke trails, knots and swirls that look like brushstrokes from an unseen painter. You drift through them as though wandering inside a cathedral, the air thick with incense, every mote catching the light of the ancient candles. It's impossible not to feel reverence. But the dust carries weightier implications too. If metals appeared this early, then planets could have begun forming far sooner than expected. Earth itself owes its rocks, oceans, and even your body to heavy elements. Without dust, no iron in your blood, no oxygen to breathe, no carbon for your cells. which means Webb's discovery hints that the ingredients for life may have been sprinkled across the universe billions of years earlier than anyone thought. The cosmic cookbook was stocked from day one. You pause to let that sink in. Life could have had a head start. Somewhere out there, civilizations might have arisen when Earth itself was still molten. You can't help grinning at the thought, aliens older than dirt, literally. They'd probably roll their eyes at our fumbling attempts to grasp cosmic timelines. Your mind drifts back to the sensory details. You feel the dust brushing against you, though you know it's an illusion. If you could touch it, the grains would feel rough, crystalline, sometimes laced with ices, and though it looks like a haze, it isn't thick. The particles are separated by miles, yet they work together to block light. It's the ultimate cosmic camouflage, hiding galaxies until the right eyes, Webb's eyes, can pierce the veil. Another joke nudges in. You imagine cosmic dust bunnies, gathering in the corners of the universe under neglected couches of space-time. The universe really does need a giant vacuum cleaner, or maybe Webb is that cleaner, revealing all the embarrassing clutter we didn't expect. Still, the awe outweighs the humour. You think of stardust as the most poetic of all scientific truths, that your body, your bones, your breath are made of the same material. Carl Sagan was right when he said you are star stuff, but Webb pushes the timeline even further. You are ancient star stuff, dust older than imagination, dust that began swirling almost as soon as the universe drew its first breath. You picture early stars exploding, scattering metals across vast distances, like fireworks celebrating the universe's survival past infancy. And in their ashes, this dust forms clouds, which collapse again into new stars and planets. The cycle begins early, furious, unstoppable. You realise that creation and destruction are not opposites here. They're partners in a cosmic waltz. Historians still argue whether humanity is ready to face the implications. If life had billions of extra years to emerge elsewhere, then the silence of the skies becomes even more haunting. Where is everyone? Perhaps civilizations rise and fall like sparks in these dusty clouds, too brief to overlap with ours. Or perhaps they're hidden, just as stars are hidden behind the dust, waiting for the right telescope to reveal them. A final joke lightens the mood. You imagine an alien housekeeper somewhere, waving a feather duster at their telescope, muttering, "Ugh, more dust. Doesn't this universe ever clean up after itself?" You chuckle, then let the laughter fade into quiet. The dust thickens around you, a velvet curtain lit by faint red glow. It feels less like a mystery now, and more like a promise, that the universe has always been fertile, always ready to create, always battering seeds in every direction. And as you drift onward, the haze begins to thin. Beyond it, you sense another presence rising. Not galaxies this time, but something darker, hungrier, more formidable. Black holes. You steady yourself, because the next revelation will not be soft dust, but roaring giants waking far earlier than you thought possible. You drift beyond the gauzy curtains of dust, expecting perhaps a clearing, a breath of quiet space. Instead, the darkness deepens, and at its heart you feel a pull. Subtle at first, like the tug of a tide, but then stronger, irresistible. You steady yourself, though you know it's only imagination guiding you here. The truth Webb has revealed is almost unthinkable. Black holes, giants, ravenous, fully formed, already prowling the cosmos just a few 100 million years after the Big Bang. You whisper to yourself that this shouldn't be possible. Black holes of modest size, sure. Stars collapse, their cores implode and gravity wins. But the monsters Webb has detected, millions, even billions of times the sun's mass, should require far more time to grow. They're like toddlers showing up at kindergarten already 6 feet tall and demanding car keys. The first quasar Webb glimpsed in this early epoch shines like a lighthouse, powered by a supermassive black hole gulping matter faster than theories comfortably allow. It radiates with the brilliance of a trillion suns. An object so bright it should feel paradoxical, something defined by darkness blazing across space. You stare at it in awe, as though the cosmos cracked a joke only it can understand. You recall a mainstream historical fact. In 1963, astronomer Martin Schmidt identified the first quasar, realizing that the faint star-like point in his telescope was actually a distant galaxy with the central engine brighter than everything around it. At the time, no one could quite believe it. And now, half a century later, Webb is repeating that astonishment at even greater distances. Quasars are not late arrivals, They're present at the very dawn. A quirky tidbit pops into your head. Some astronomers, when they first discovered quasars, jokingly called them quasi-stellar radio sources because they didn't fit any category. The nickname stuck, even though not all quasars emit strong radio waves. You smile at the thought that even the most terrifying beasts in the universe got stuck with a name that sounds like a half-hearted shrug. Quasi-something. It's as if someone saw a dragon and decided to call it a sort of lizard. The scholarly debates here are fiery. How could black holes this massive appear so soon? One camp argues that maybe the first stars, the giant population 3 stars, collapsed directly into large black holes, skipping the modest middle step. Another proposes direct collapse black holes, where vast gas clouds folded into themselves without ever forming stars. Others mutter that maybe we've underestimated just how greedily black holes can feed, gobbling matter at rates thought impossible. Historians still argue whether this puzzle requires new physics or simply a humbler adjustment to our imaginations. And here comes your first joke. You picture astrophysicists around the world staring at Webb's data like frustrated parents, muttering, "You're too young to be this big." The universe, of course, doesn't care. It just keeps spawning overachievers. The strange thing about black holes is how paradoxical they are. They're defined as places where light cannot escape, yet when matter swirls around them, the friction heats it into a radiance visible across billions of light years. They're both invisible and dazzling, destructive and creative. You think of them less as monsters now, and more as chaotic artists, painting galaxies with gravity. Still, the scale unsettles you. One black hole Webb has hinted at weighs hundreds of millions of suns. To put that in perspective, if you replace the Sun in our solar system with such a black hole, its event horizon would stretch beyond the orbit of Mercury. Earth would circle inside a shadow too vast to comprehend, bathed in lethal radiation. You shiver and tuck your blanket closer, grateful for the quiet, ordinary star you actually orbit. Another light joke drifts in. People back on Earth complain when their Wi-Fi goes down for 5 minutes. Here, you're staring at black holes that gulp entire galaxies, and you think maybe our definition of problems could use a little recalibration. The presence of early black holes also changes the story of galaxies. Are they the seeds that galaxies grow around, anchoring stars in their grip? Or are they latecomers, born from the collapse of dense stellar neighbourhoods? Webb's images don't settle the argument, they sharpen it. In some places, black holes seem to dominate first, as if the galaxy is an afterthought. In others, they appear as natural consequences of star formation. You feel the tension of a cosmic chicken and egg problem. Historians still argue whether humanity is even framing the question correctly. Maybe which came first is too simplistic for something as messy as the early universe. Maybe galaxies and black holes grew hand in hand, partners rather than rivals. You like that image? Not chicken and egg, but 2 dancers, twirling through time, each shaping the other's steps. Another quirky tidbit slips in. Astronomers recently discovered a black hole nicknamed J2147 that eats a star's worth of matter every day. It's one of the hungriest ever observed. You laugh softly, imagining it as the cosmic equivalent of an all-you-can-eat buffet champion, a record holder in intergalactic gluttony. Somewhere, surely, a cosmic weight loss program is needed. But behind the humour you feel the awe again, because these black holes are not just curiosities, they're engines of evolution. Their radiation can heat and blow gas away, stifling star formation, or compress and trigger new bursts of stars. They shape galaxies the way volcanoes shape islands, destructive, creative, impossible to ignore. Your eyelids grow heavy as you linger on the paradox. The early universe, instead of being fragile and tentative, seems almost impatient. Dust formed too early, galaxies grew too fast, and now black holes too massive too soon. It's as though the cosmos, in its first billion years, sprinted out of the gate while humans are only now catching up to watch. Here's your third joke to soften the weight. You imagine the universe as a student turning in its homework weeks before the deadline, neat handwriting, extra credit problems solved. Meanwhile, humans are still trying to find the right page in the textbook. You let yourself drift closer to one of these early quasars. Its light blazes, scarlet and white, smeared by distance, humming with a power that feels less like a star and more like a siren. You don't fall in, you couldn't, but you sense the pull, the invitation to cross into the unknowable. You stop yourself at the edge, marveling at the quiet violence that makes existence possible. And as the glow fades behind you, you sense the next revelation on the horizon. Not the darkness of black holes, but the strange geometries of galaxies already forming shapes too soon. Spirals where there should only be chaos. Order sneaking in early, bending the script once again. You drift away from the roaring quasars, still feeling their gravitational echo tugging faintly at your thoughts. Ahead, you expect to find chaos. After all, the universe is still young here, barely out of its cosmic cradle. Galaxies should be amorphous blobs, clumps of stars without order, messy splashes of light. But as Webb's vision sharpens, your eyes widen. Spirals, disks, shapes with symmetry and structure appear centuries, no billions of years, before they're supposed to. It's like stumbling into a toddler's playroom and finding neatly alphabetized books, color-coded toys, and a balanced checkbook on the desk. You stare, suspicious. The early universe was supposed to be chaotic, so who tidied up? One galaxy in particular spins before you like a pinwheel, arms curling gracefully out from a bright core. The arms are clumpy, yes, but undeniably spiral. A geometry scientist thought would take eons to emerge. Spirals are delicate structures, requiring time for rotation and gravity to settle into harmony. Yet here it is, a cosmic ballerina pirouetting while the stage crew is still hammering the set. The scholarly debates are fierce. Some astronomers argue these spirals must be illusions, patterns created by chance alignments or by gravitational lensing, distorting background galaxies. Others insist Webb is really showing us that order arrived early, that disks and spirals formed in a fraction of the expected time. Historians still argue whether this discovery will demand rewriting the entire timeline of galactic evolution, or whether it's just another tweak to models that already bend like yoga instructors. You think of a mainstream historical fact. In 1845, Irish astronomer William Parsons, the 3rd Earl of Ross, sketched the first spiral nebulae with his massive Leviathan of Parsonstown telescope. He had no idea they were galaxies beyond the Milky Way, but he recognised their swirling form. Now, centuries later, you see spirals even earlier than his sketches dared imagine. Parsons would have gasped, probably dropped his pencil, and demanded a larger telescope immediately. A quirky tidbit bubbles up. Some galaxies seen through Webb look so much like fried eggs. Bright yolk in the centre, flattened disk around, that astronomers actually call them sunny-side-up galaxies. You chuckle, picturing the early universe as a cosmic breakfast buffet. Apparently, order and omelettes were on the menu sooner than expected. But behind the humour, you feel awe. Spirals aren't just pretty shapes. They're evidence of stability, balance, and rotation. To form them, matter must collapse smoothly, gas must cool efficiently, and stars must settle into orbits without being shredded by violent collisions. It's as if the universe was building cathedrals of light while still learning how to mix the mortar. Your first joke sneaks in. Somewhere, an astrophysicist is sighing at their equations, muttering, "I told you it would take 1 billion years," while Webb smugly flashes a spiral saying, "Surprise, it only took 300 million. The cosmos is a prankster with very expensive props. The more you look, the more geometries appear. Some galaxies show elongated bars funneling gas into their cores. Others hint at rings, delicate circles carved into starfields. Each one seems to wink at you, saying, "Bet you didn't expect this so soon." And indeed, you didn't. You pause to let your imagination wander. Maybe the universe simply doesn't like chaos as much as humans do. Maybe symmetry is its default, an instinct written into the math of gravity itself. Or maybe Webb is simply pulling back the curtain on order that was always there, hidden behind dust and distance, waiting for the right eyes to notice. Historians still argue whether we should treat these spirals as rare gems, lucky finds in a sea of chaos, or whether they represent a fundamental truth that order coalesces faster than we believed. You lean toward the latter. After all, the universe has a track record of humbling human timelines. You recall another historical echo. The philosopher Immanuel Kant in the 1700s speculated that spiral nebulae might be island universes. He was mocked for it, since the Milky Way was assumed to be all there was. Now you hover over spirals formed billions of years before Kant even had the thought. The irony makes you smile. Here comes your second joke. Humans take years to organise closets, and the job usually collapses after a week. Yet galaxies with billions of stars manage to keep their spirals tidy for billions of years. The universe clearly has better housekeeping skills than you do. A quirky vision pops in. If you could step into one of these early spirals, you might walk across lanes of newborn stars arranged like glowing highways. Dust lanes would arch above you like Gothic arches, gas clouds would burn in neon, and the rotation of the disk would carry you slowly around a central hub. It would feel like standing inside a glowing Ferris wheel, except you'd never come down. The scholarly debates return, buzzing in your ears. Could turbulence in the early gas actually accelerate order rather than delay it? Could dark matter halos act like scaffolding, holding galaxies steady while their spirals spin? Or, this is the more radical suggestion, have we misunderstood the very physics of rotation in the early universe? Theories swirl as fast as the galaxies themselves, each one elegant, each one incomplete. Your third joke sneaks out before you can stop it. If these spirals are really this early, then the universe clearly didn't need billions of years of practice. It's like someone learning to ride a bike and nailing the Tour de France on their first try. You can almost hear cosmologists groaning, "Show off." You float above a spiral, watching it turn. The motion is so slow, yet so steady, that it feels eternal. Stars drift like grains of sand in a tide, pulled along paths carved by invisible hands. The symmetry is hypnotic, lulling your thoughts into soft circles. But even as your eyelids grow heavier, the paradox sharpens. Order and chaos, born together. Galaxies too fast, too bright, too structured. Black holes too big, dust too early. Everywhere you look, the universe is ahead of schedule, rewriting its story in bold strokes. And as you drift onward, the spirals fade behind you, replaced by another kind of wonder: colour. Webb doesn't just reveal shapes, it reveals hues invisible to human eyes. Ahead, the first dawn glows not in white or yellow, but in shades of deep crimson, amber and violet, the palette of creation itself. The spirals fade behind you, their graceful arms dissolving into the wider dark. And ahead, a new kind of spectacle rises. Not shape this time, but colour. You've grown used to thinking of space as black and white, pinpricks of light against endless dark. Maybe a faint blue nebula here or a golden star there. But Webb doesn't see the universe that way. Its eyes tuned to infrared, wavelengths stretched by billions of years of expansion, hues invisible to human sight. And what it shows you now is a dawn painted in colours you've never seen before. Deep crimsons glow like embers smouldering where dust hides newborn stars. Amber bands curl through gas clouds, thick and warm as honey poured in slow motion. Somewhere in the mix, hints of violet shimmer, faint but defiant, like neon streaks in an ancient night. You hover there, stunned, because this palette doesn't belong to any earthly dawn. It's a spectrum born of physics, of light stretched and shifted by the universe's own expansion. The sight is intimate, almost sensual, not in a romantic way, but in the way colour presses against your eyes. Whispering stories of atoms colliding, hydrogen igniting, dust scattering. It feels less like looking and more like tasting light. You let it wash over you, each wavelength a flavour. The sweet red of star nurseries, the bitter orange of cosmic dust, the metallic edge of ultraviolet light just beyond your reach. You pause to laugh softly at yourself. Back on Earth, people argue endlessly about which Instagram filter makes breakfast look better. Here, the cosmos has been filtering its own light for 13 billion years, no app required. If Webb had a tagline, it might read, "No filter, just reality." The scholarly debates hum beneath the colours. Some astronomers insist these infrared hues tell us not just about distance, but about composition. Different elements emit different colours when energised. Others argue the colours in Webb's processed images are translations, chosen by scientists to represent infrared in a visible palette. Historians still argue whether this translation counts as true colour, or as art layered over data. You don't mind either way, the effect is breathtaking. A mainstream historical fact drifts into your thoughts. In the 1660s, Isaac Newton passed sunlight through a prism and discovered it spread into a rainbow. That was the beginning of spectroscopy, the science of reading the universe's secrets through light. Every hue holds a signature, every shade a barcode of atoms. Tonight, floating through Webb's dawn, you're living inside Newton's prism, only stretched across the entire cosmos. He saw 7 bands of colour, you see billions. A quirky tidbit makes you grin. Some of the faintest galaxies Webb detects are so redshifted that astronomers joke they're ultra-red things. That's the technical nickname, no fancy Latin. Just things. You picture a team of brilliant scientists shrugging at data and saying, it's really red. Let's just call it that. The universe is profound, but sometimes its discoverers are delightfully lazy with names. The first joke drifts naturally. You imagine trying to describe these colours to someone who's never seen them. It's kind of like red, but older. Not exactly a paint swatch description. Somewhere an art teacher is groaning. Still, the colours are more than aesthetics. They're maps of creation. The reds mark hydrogen gas, glowing faintly as stars ignite. The yellows trace dust warmed by starlight. The blues, when they appear, reveal energetic newborn stars. Webb isn't just giving you pretty pictures. It's decoding the very chemistry of the dawn. You realise you're not staring at a canvas. You're staring at a laboratory report written in light. The scholarly debates circle again. Some researchers argue the abundance of colours proves early star formation was faster and richer than expected. Others suggest perhaps our models of dust absorption are incomplete, skewing the hues. And a few, ever the skeptics, wonder if some of the most vibrant shades are artefacts of Webb's detectors. The argument feels like wine critics bickering notes of cherry no, definitely tobacco. Meanwhile, you sip quietly and enjoying the flavour of the cosmos without needing a perfect label. Your second joke slips in. You think of humans proudly naming colours like seafoam or eggshell white. Imagine trying to sell 13.5 billion-year-old hydrogen burnt orange as a paint swatch at a hardware store. The DIY aisle would never recover. But beyond humour, you feel awe at the simple truth. The universe is not monochrome. It is radiant, layered, expressive. If humans had evolved infrared vision, perhaps mythology and art would have been drenched in deeper hues, entire cultures shaped by colours most of us will never naturally see. You wonder if somewhere out there, alien eyes evolved to see this spectrum natively, experiencing every sunrise as a Webb image. A historical echo joins the thought. Ancient people often painted their gods in radiant reds and golds, associating those colours with power and creation. They couldn't have known it, but they chose the same palette, now glowing in Webb's first dawn. Perhaps instinctively, humans always sensed that red was the colour of beginnings. Your third joke arrives gently. You imagine some early astronomer reporting the first dawn was mostly beige. Luckily, Webb has rescued you from that nightmare. Beige may have its place in living room carpets, but not in the story of creation. You let the colours deepen, blending into one another, waves of hue rolling like music. If sound had colour, this is what it might look like. Symphonies painted across the dark. And in that realisation comes a quiet peace. The universe is not only intelligible, it is beautiful, extravagantly so. Even its chemistry sings. As your eyelids grow heavier, you sense the next stage waiting. Beyond this painted dawn lies something darker, the so-called cosmic dark ages, a time before light had fully broken free, before galaxies blazed openly. You shiver slightly, but not from fear. It feels like stepping back further into memory, toward a silence so deep it borders on nothingness. And so you let the colours fade, their warmth dissolving into cool darkness. Ahead, the universe waits in shadow, patient, still cloaked in its earliest obscurity. The dark ages beckon, and you drift willingly into their quiet embrace. The colours of dawn fade behind you, dimming until the palette dissolves into shadows. What replaces them is not silence exactly, but something heavier, a hush that feels absolute, like walking into a cathedral before anyone has lit the candles. This is the epoch astronomers call the cosmic dark ages. You feel it immediately, the absence of starlight, the suffocating quiet of a universe that hasn't yet figured out how to shine. Imagine drifting through a fog so thick you can't tell whether you're moving. Gas stretches everywhere, hydrogen and helium smeared across the cosmos, but no galaxies sparkle, no stars flicker. The universe is full of matter, yet empty of illumination. It's the longest lights off in history. You float through it slowly, almost reverently, as if afraid to break the silence. The Dark Ages began roughly 380,000 years after the Big Bang. once the universe had cooled enough for electrons and protons to join into neutral atoms. Before that, light scattered endlessly, bouncing off free particles like a flashlight beam in smoke. But once atoms formed, photons slipped free, creating the cosmic microwave background. The afterglow astronomers still measure today. Then came this long pause. No stars, no galaxies, just endless night. A mainstream historical fact pops into your mind in 1965. Arno Penzias and Robert Wilson accidentally discovered that very afterglow, the cosmic microwave background, while working on a radio antenna in New Jersey. They thought at first it was interference, even blamed it on pigeon droppings inside the dish. They cleaned it, but the noise never went away. It turned out to be the oldest light in the universe. You can't help chuckling. Humanity's window into the dawn of time almost got scrubbed away with a broom and bucket. Here's your first joke. You picture those pigeons smugly flapping around whispering, "We helped discover the universe, you're welcome." Somewhere in the annals of history, 2 birds deserve honorary astrophysics degrees. Still, the Dark Ages linger far beyond that discovery. For hundreds of millions of years, the cosmos drifted in this half-silence, waiting for gravity to gather gas into the first stars. You hover in that waiting room now, and it feels eerie. The gas is cool, neutral, invisible. Webb can't see it directly, though it can glimpse the edges where starlight finally begins to break through. What you experience is the anticipation of creation, the inhale before the shout. The scholarly debates surround this era like whispers in the dark. Some scientists argue that the first stars may have lit up earlier than Webb suggests, small and faint, hidden behind clouds of gas. Others think the Dark Ages lasted longer, that light had to struggle for far more time before breaking free. Historians still argue whether we've nailed down the timeline or whether we're fumbling in guesswork, reconstructing the earliest history from shadows. A quirky tidbit floats to you. One of the ways scientists hope to study the Dark Ages is by listening to the faint 21 centimetre line, a specific radio signal emitted by neutral hydrogen. It's like the atoms are whispering their presence in a frequency too subtle for ordinary eyes. Radio telescopes on Earth and in orbit strain to catch that whisper. You imagine the universe gossiping softly, muttering, "Yes, I was here," long before the lights turned on. The loneliness of this time seeps into you. No stars means no heavy elements, no planets, no life. Just endless hydrogen and helium stretched thin across space. You feel the weight of it, the emptiness, the patience required. It's humbling because humans complain when Wi-Fi takes 30 seconds to load a page. Yet here the cosmos waited hundreds of millions of years just to make its first spark. That sparks your second joke. You imagine early atoms sitting around playing cosmic board games, sighing, "When will the lights come on?" Hydrogen rolls the dice. Helium yawns. Somewhere gravity is the dealer, biding its time. The Dark Ages were not truly silent, though. Gravity was at work in the background, tugging, pulling, slowly coaxing gas into denser clumps. Dark matter, silent, invisible, acted as scaffolding, cradling clouds of hydrogen until they grew dense enough to ignite. You drift near one of these invisible cocoons, sensing its weight though you can't see it. It feels like leaning against a wall in the dark, unseen but undeniably there. Historians still argue whether dark matter alone explains the structure of the cosmos, or whether some deeper physics is hiding in plain sight. Perhaps exotic particles played a role, or perhaps gravity itself behaves differently on large scales. You like the thought that even in this most silent of eras, mysteries piled up, waiting billions of years for you to ask the right questions. Your third joke bubbles up. If the Dark Ages lasted hundreds of millions of years, maybe the universe was just napping. A very long nap. Yes, but who among us hasn't overslept? You can almost hear the cosmos mutter groggily 5 more minutes before finally rolling over and igniting stars. The stillness presses against you now, but you don't feel afraid. Instead, it's oddly soothing. The Dark Ages are like a blank canvas stretched across infinity, waiting for the first strokes of light. It reminds you of seconds before a symphony begins, charged, anticipatory, sacred, and then, faintly, you sense it. The first flicker of brightness bleeding through the dark. Not many stars, not yet, but enough to glow like fireflies at the edge of a meadow. The Dark Ages are ending, and the next act, Ryanization's glow, is about to begin. You drift toward it eagerly, ready to watch the universe turn its lights back on. The darkness around you lingers, thick and ancient, but something stirs. At first it's subtle, a faint shimmer like distant sparks hidden behind a veil. Then the sparks multiply, brightening, pushing at the edges of the fog. You realise you're drifting into the moment astronomers call reionization, the grand switch on, when the first stars and galaxies broke through the cosmic gloom and flooded the universe with light. It doesn't happen all at once. The first stars flare like campfires scattered across a black field, each one ionizing the gas around it, peeling electrons off atoms and carving glowing bubbles into the darkness. You drift through one such bubble now, and it feels like stepping into a lantern. Hydrogen gas that once blocked light is suddenly transparent, the fog burned away by ultraviolet radiation. Multiply this by billions, and soon the entire universe is clear. It's hard not to get swept up in the drama. For hundreds of millions of years, the cosmos held its breath. Then, in a few hundred million more, it exhaled photons, ripping open the dark ages. You imagine the universe as a theatre audience, hushed in silence, and then suddenly every phone flashlight turns on at once. Blinding, chaotic, exhilarating. A mainstream historical fact steadies your awe. In the early 2000s, the Wilkinson Microwave Anisotropy Probe, WMAP, and later the Planck satellite mapped the faint afterglow of the Big Bang and hinted at when reionization began, around 400 to 800 million years after the universe's birth. Those missions couldn't see the galaxies directly, only infer the timing from the way free electrons scattered microwave light. Webb's, though, is finally showing you the actual actors in the play, the galaxies responsible for turning the lights on. Here's your first joke. You can't help but compare it to humanity's obsession with light switches. Flick a switch, the room glows. Forget to pay the electric bill, the room darkens. The universe, apparently, invented this drama billions of years before Edison ever thought of a filament. The scholarly debates flicker in like background static. Did reionization happen quickly, in a sudden blaze, or gradually, with overlapping bubbles of light spreading across billions of years? Some researchers argue small dwarf galaxies did most of the heavy lifting, ionizing huge swaths of hydrogen with their radiation. Others point to quasars powered by monster black holes as the main culprits. Historians still argue whether this cosmic dawn was a smooth sunrise or a patchy mosaic of flickers. You lean toward the mosaic because Webb's images show it vividly, glowing regions surrounded by untouched darkness, like lanterns hung at irregular intervals across a cave. You drift between them, each bubble a doorway to clarity, each one reminding you of how fragile light can be when it first begins. A quirky tidbit makes you smile. Astronomers sometimes call this period the Epoch of Reionization, which sounds far grander than it looks, like the title of a lost sci-fi novel. You imagine a paperback on a dusty shelf. Epoch of Reionization, the battle for photons. Somewhere, a screenwriter is missing out on the best title of their career. Your second joke slips out. You picture early stars filing paperwork with cosmic authorities. Dear Universe, I would like to ionize my local hydrogen. Permission granted? The bureaucracy of physics, rubber stamped by photons. But the seriousness presses in. Without reionization, the universe would have remained opaque. Light from galaxies would be trapped, unable to travel, the cosmos forever cloaked in fog. Everything you're seeing now, spirals, quasars, dusty nurseries, depends on this era when hydrogen surrendered its electrons. In a sense, reionization is the true beginning of visibility. Before this, the universe existed but couldn't be seen. Historians still argue whether we fully understand the mechanics. Did exotic particles or faint processes also contribute? Could dark matter annihilation play a role? The questions linger like shadows on the edge of the glowing bubbles. Even in illumination, mystery survives. Your third joke arrives with a grin. You think of the universe at this moment as a teenager discovering electricity for the first time. Look, I can turn the lights on. And then it never stops. Blazing galaxies ever since. The cosmic dark ages were the bedtime. Reionization was the rebellious wake-up call. You linger, floating in one of the glowing pockets, watching gas shimmer as electrons scatter. The light feels soft, almost damp, as though you're swimming through liquid brightness. It reminds you of bioluminescent plankton in the ocean, tiny organisms lighting up the water, except here the plankton are galaxies, and the ocean is infinite. it occurs to you that life itself might owe its chance to this very moment. Without transparency, light could not spread, stars could not influence distant matter, and chemistry might have stayed locked in the dark. Ionization was not just a technical phase, it was permission for complexity to unfold. A historical echo joins in. When humans invented fire, they pushed back their own dark ages, scattering shadows, lengthening their days. The universe did something similar here, though on a scale that dwarfs every campfire ever built. Both stories, the human and the cosmic, begin with a spark and you breathe slowly, letting the light of the first dawn settle into you. It's easy to romanticize, but you remember the violence too. Ultraviolet photons stripping electrons, galaxies blasting radiation, gas clouds shredded by heat. Creation, it seems, always walks hand in hand with destruction. And then, almost without warning, the glow softens. You're drifting beyond the reionization bubbles now into clearer space. The universe looks brighter, yes, but also stranger. Distances stretch, timescales blur, and your sense of forward and backward begins to wobble. You realize that staring this far into time is like bending a mirror. You can't quite tell where the present ends and the past begins. The lights are on, the fog is gone, and you're about to discover that when you stare hard enough into the beginning, time itself starts to unravel. The fog of reionization fades behind you, and for a moment the view feels clear. Almost too clear. Galaxies burn in the distance, quasars roar, spirals spin, but as you gaze deeper, something odd begins to happen. Distances stretch like taffy, timelines fold over themselves, and the sense of before, after starts to blur. You realize this is the strangest part of Webb's discoveries. When you look far enough back, time itself feels as though it's running in reverse. It's not that the universe is actually rewinding, of course, it's the way light carries memory. Every photon Webb captures has been travelling for billions of years, bringing you a snapshot of the past. You're always seeing history, never the present. And the deeper Webb stares, the further back that history goes, until you're peering at events that occurred just a few 100 million years after the Big Bang. You are quite literally watching time play backward like a film on rewind. But here's the twist. Some galaxies in Webb's images look older than they should. They seem too mature, too developed for their place in the timeline. It's as if you've rewound a movie to the opening credits and found the characters already wrinkled, sipping tea in retirement. Time is supposed to run forward, but the evidence here makes it feel slippery, uncertain. A mainstream historical fact grounds you. In 1905, Albert Einstein's special relativity redefined time as something flexible intertwined with space. Time could stretch or compress depending on motion and gravity. A century later, Webb is giving you front-row evidence of that truth. Space expands, light stretches, and the neat tick-tock of clocks breaks down when measured against billions of years. Here's your first joke. You picture an astrophysicist sighing, "Great, now time itself is broken. Someone call customer service." You imagine being stuck on hold with cosmic elevator music, waiting to speak with the universe's manager. The scholarly debates buzz louder than ever. Are these two old galaxies evidence that we've miscalculated cosmic expansion rates? Could it be that time unfolded differently in the early universe, with processes happening faster than expected? Some even speculate that our models of redshift, the way light stretches as the universe expands, might be incomplete. Historians still argue whether Webb is simply pointing out bookkeeping errors or exposing something fundamentally new about reality. A quirky tidbit sneaks into your thoughts. Certain galaxies observed by Webb appear so stretched and smeared by gravitational lensing that they've been nicknamed cosmic noodles. You grin because nothing says cutting-edge astrophysics like pasta metaphors. The universe may bend time and space, but humans will always describe it like dinner. The second joke arrives naturally. If time really is this flexible, you wonder if you can use it as an excuse. "Sorry I'm late, but you see, time dilation in my kitchen threw me off." Somewhere a physicist's spouse is rolling their eyes. Yet the deeper you float, the stranger it feels. Webb's gaze isn't a clean rewind, it's layered, tangled. Some galaxies appear in multiple places at once, their light bent by intervening clusters, showing you both younger and older versions of themselves. You realize you're looking at echoes, the same object seen at different stages, overlapping like a double exposure. It's dizzying, like standing in a hall of mirrors where every reflection is you, but slightly older, slightly altered. Historians still argue whether this sense of overlapping timelines is simply a quirk of lensing, or whether it hints at something more profound about space-time itself. Maybe the universe is less like a neat timeline and more like a tapestry, woven with threads that cross and loop. Webb, then, isn't showing you a rewind so much as the weaving itself. Your third joke slips in gently. You imagine asking the universe, "So, what time is it really?" And the cosmos replying, "Yes," is the only answer that fits. Still, you can't shake the awe. Watching time run backward reminds you of your own fragility. Your life ticks forward, one heartbeat after another, with no rewind button. But here, the cosmos casually offers glimpses of beginnings older than Earth, older than stars, older than atoms in your body. You're reminded that time is not uniform, it is elastic, relative, and indifferent to human clocks. A historical echo deepens the thought. In ancient India, some philosophies imagined time as cyclical, repeating endlessly in vast cosmic ages. In contrast, Western thought often saw time as linear, marching forward from creation to conclusion. Tonight, Webb shows you both. Linear light travelling back in time, yet looping in patterns that feel cyclical. The old arguments seem less like philosophy and more like foresight. You close your eyes for a moment and let yourself imagine the reversal more literally. Galaxies shrink, stars collapse back into clouds, dust gathers into smooth hydrogen seas, light fades into darkness. Rewind far enough and everything condenses into a single point, the Big Bang itself. You can almost hear the tape whirring, the film spooling back onto its reel. But when you open your eyes, you realize the truth is subtler. Time isn't really rewinding. You're just finally seeing what was always there. History still in transit, photons still on their journey. You're not bending time, you're catching up to it. And yet, there's comfort here. If light can survive billions of years, crossing unimaginable gulfs to reach you, then maybe your own fleeting moments are not so fragile. They too ripple outward, faint but real, part of the same continuum. You drift onward, letting the paradox soften into calm. Behind you, dawn has broken. Around you, time folds and stretches. Ahead lies a harder truth. If galaxies form too fast, if dust arrives too early, if black holes awaken too soon, then maybe our beloved theories are wobbling. Maybe the story of the universe isn't as neat as we thought. The stage is set not just for wonder, but for fracture. You sense it waiting in the distance. The unravelling of models, the questioning of foundations. The light is steady, but the ground beneath science trembles. You drift through the tangled fabric of time, still dizzy from watching galaxies look too old, too soon, and you realise the consequence is unavoidable. Theories are beginning to wobble. Models that once felt unshakable, whole equations etched in stone in lecture halls, now show cracks under the weight of Webb's revelations. It feels like standing in a museum watching statues tilt precariously, priceless works of thought suddenly one tremor away from shattering. Scientists don't use the word panic in their papers, of course, they dress it up as tensions or anomalies. But as you float in the aftermath of Webb's discoveries, you can almost hear the murmur. This doesn't fit. This shouldn't be here. Our beautiful timeline has teeth marks all over it. The galaxies are too bright, the dust too early, the black holes too massive, the spirals too neat. One puzzle would be fine, science loves puzzles, but all of them at once, and that's a cosmic prank. You almost suspect the universe is trolling you, as if it read the textbooks and decided to contradict them on purpose. Your first joke slips in. You imagine the universe posting online, new Webb data just dropped. Let's watch the physicists cry. Comments flood in from galaxies, stars, and rogue photons, all laughing emojis. Somewhere the cosmos has a very shrill sense of humour. A mainstream historical fact drifts through your mind. In the early 20th century, astronomers debated whether the universe was static or dynamic. Einstein originally added his cosmological constant to fix his equations, keeping the cosmos steady. Then Hubble discovered galaxies rushing away, forcing Einstein to call his constant the greatest blunder. Tonight, watching Webb fracture modern models, you wonder, whose blunder are we about to discover now? The scholarly debates are intense. Some argue these fractures will mend with the better data. Perhaps Webb's findings are exceptional cases, outliers, galaxies boosted by gravitational lensing. Others think the problems are real but solvable with tweaks. Maybe dark matter clumped earlier, maybe star formation is more efficient, maybe black holes are greedier than assumed. And then there are the radicals, whispering that the entire lambda CDM model, the standard cosmology of dark matter, dark energy and cold beginnings, might need replacement. Historians still argue whether this is the first tremor of revolution or just a passing hiccup. A quirky tidbit softens the weight. When physicists can't explain something, they often give it playful placeholder names. Dark matter, dark energy, labels for ignorance wrapped in mystery. Recently, some even tossed around the phrase early dark energy to patch holes into the cosmic timeline. You grin at the irony. When in doubt, slap dark in front of it and hope for the best. Somewhere surely, a graduate student has suggested dark coffee as the true solution. Your second joke comes naturally. You picture cosmology as a group project. Everyone agreed on the assignment: explain the universe. Half the team did their part neatly, the other half forgot, and now Webb just turned in a surprise appendix full of contradictions. The professor, reality itself, just scribbled, "See me after class." But behind the humour you sense the fragility of human understanding. For decades, cosmology has operated on a neat framework: a big bang, an expanding universe, dark matter, scaffolding, dark energy accelerating. Webb didn't erase that framework, but it sprayed graffiti all over it. Too fast, too bright, too soon. The graffiti glows in neon across the sky, and you realise it cannot be ignored. Historians still argue whether scientists cling to old models too tightly. Thomas Kuhn once wrote about paradigm shifts, moments when old theories collapse under contradictions and new ones rise. Are you living through one of those, or is this merely the messy process of science doing what it does best? Adapting, refining, wobbling without collapsing. The answer, of course, hasn't arrived yet. You float in suspense. Your third joke bubbles up. You think of all the textbooks printed in the last decade, all the tidy diagrams of galaxy formation, and you imagine a giant cosmic hand reaching down to stamp them with a red LOL, try again. Somewhere, publishers are groaning at the cost of rewriting every chapter. Yet amid the fractures, beauty persists. Science isn't breaking, it's bending like glass under heat, kit ready to be reshaped. You realise the fractures are not failures but obvious opportunities. Clues that the universe is deeper, stranger and more generous than you dared expect. A historical echo joins your thoughts. When Copernicus proposed a sun-centred system, it broke centuries of Earth-centred certainty. The fractures then were enormous, but they birthed modern astronomy. Tonight, drifting through Webb's revelations, you feel the same tremor. A shift as profound as moving Earth from the centre of the map. You close your eyes for a moment, listening. The fractures don't sound like destruction, they sound like music, discordant notes pressing scientists to compose a richer symphony. Confusion, after all, is where discovery begins. But still, questions gnaw. If galaxies formed too soon, if dust came too early, if time itself feels bent, what else could be true? You sense the whispers growing louder, the fringe ideas daring to step forward, multiverses, alternate dimensions, realities beyond this one. The fractures widen into possibilities, and you find yourself drifting toward them, curious to see what leaks through the cracks. The fractures in theory don't just expose gaps, they open doors, and as you drift closer you sense something almost scandalous waiting behind them. If the early universe defies the neat story of galaxies forming on schedule, dust arriving politely, and black holes behaving themselves, maybe the answer isn't just a tweak to equations, maybe the answer is wilder. The whispers gather around you, hushed but insistent. Alternate universes. It sounds absurd, the kind of idea scribbled on a late-night napkin after too much coffee. And yet, the more you stare at Webb's data, the harder it is to dismiss the thought. What if the anomalies you see aren't just mistakes in our timeline, but echoes of other ones? Universes brushing against ours, leaving fingerprints in the light. You imagine it vividly, overlapping fabrics of reality, each with its own rules, bumping gently like bubbles in a cosmic sink. Perhaps our universe formed next to others, each expanding, colliding, leaving scars we now mistake for contradictions. The galaxies too bright, the spirals too soon, the black holes too massive. Maybe they're not glitches, but graffiti from another cosmos tagging our wall. A mainstream historical fact grounds your wonder. In the 1950s, Hugh Everett proposed the many worlds interpretation of quantum mechanics, suggesting that every possible outcome of an event actually happens, spawning parallel universes. At the time, most physicists rolled their eyes. It sounded like science fiction. But decades later, the idea still refuses to die, popping up in conferences and late-night debates. Everett didn't have Webb's images, but he had the instinct to question whether our universe is the only show in town. Your first joke emerges easily. You imagine galaxies in another universe holding a viewing party, pointing their telescope back at you. Wow, look at that little smudge. What a weird cosmos they've got. Somewhere, two beings are clinking mugs of interdimensional tea, laughing at your own anomalies. The scholarly debates swirl like eddies around you. Some cosmologists argue that inflation, the rapid expansion just after the Big Bang, could naturally produce a multiverse, with different patches of space-time inflating into separate universes. Others push back, saying the multiverse is unfalsifiable, a philosophical crutch rather than a scientific theory. Historians still argue whether science should even entertain ideas that might never be directly tested. Is it bold curiosity or dangerous speculation? A quirky tidbit makes you smile. When physicists run simulations of bubble universes colliding, the predicted signature looks like faint circular patterns in the cosmic microwave background. Astronomers have scoured the data, hoping to find those rings. Some even joked about calling them bruise marks, evidence of universes bumping into one another. You picture the cosmos as a bar fight, universes trading elbows, each left with cosmic black eyes. Your second joke slips in. You wonder if this means somewhere there's a universe where Mondays don't exist. Surely that's the real paradise. Forget advanced civilizations. Just give me a timeline without alarm clocks. The multiverse idea is intoxicating but also unsettling. If other universes exist, then ours might not be special. All our careful measurements, our triumphs of understanding, could be one tiny story in a library beyond comprehension. You feel both humbled and slightly cheated, like discovering your favourite movie is only one episode in a series you'll never get to finish. Historians still argue whether humanity even needs the multiverse to explain Webb's findings. Maybe the anomalies are solvable within our own cosmos. No extra universes required. But the thought persists, whispering, what if the universe is stranger than we dare believe? Your third joke bubbles up to ease the weight. If infinite universes exist, then somewhere there's one where you never left the house today, one where you invented pizza, and one where you're actually reading this in a different voice. Somewhere one of you is asleep already, and honestly that version might have made the better choice. But you linger here, letting the possibility wash over you. The fractures in theory may not demand alternate universes, but they invite the imagination to stretch. Webb's deep gaze isn't just exposing galaxies, it's challenging the boundaries of reality itself. And even if the multiverse remains speculation, it serves as a reminder. The cosmos is always larger, always stranger, than the boxes we try to keep it in. You close your eyes for a moment and picture it. Infinite dawns, infinite galaxies, infinite versions of yourself drifting through them. Some more chaotic, some more orderly, some governed by laws you'd never recognize. And maybe, just maybe, they're peering back, their own telescopes catching faint hints of your universe, wondering why your galaxies look too bright, too soon, too odd. When you open your eyes again, the thought lingers like a dream you can't quite shake. Behind you, fractured theories still echo. Around you, whispers of multiverses hum. Ahead, you sense another possibility. Less fantastical, but no less unsettling. Maybe it isn't other universes at all. Maybe it's gravity itself, pulling strings in ways we don't yet understand. The whispers of alternate universes fade like a dream, leaving you drifting in silence again. But the silence doesn't last. Another presence hums beneath everything you've seen. Subtle, invisible, yet undeniable. It's not galaxies or stars this time, not dust or black holes. It's the hand that pulls them all together, the puppeteer tugging at every string of creation. Gravity. You feel it before you name it, a constant pressure under your thoughts. Gravity is everywhere, shaping the spirals, binding clusters, feeding black holes, bending light. And yet Webb's discoveries have left it looking mischievous, as though it might be bending more than just space. Maybe it's bending the rules themselves. Galaxies too massive too soon, clusters too crowded too early. Each anomaly points back to gravity, Did it pull harder in the beginning? Did it act faster, like a conductor rushing the orchestra through the opening notes? You imagine the cosmos as the symphony, and gravity the maestro, tapping its baton impatiently, faster, brighter, louder. A mainstream historical fact steadies your imagination. In 1687, Isaac Newton published his Principia Mathematica, describing universal gravitation. For the first time, an apple falling to the ground and the moon orbiting a Cherubas were expressed by the same law. It was a revelation, one invisible force binding the heavens and the earth. Tonight, though, you can't help but smirk. Newton's neat equations worked beautifully for apples, but galaxies billions of light years away? That's a trickier orchard. Your first joke slips in. You imagine Newton peering at Webb's data, his wig slipping askew as he mutters, "Those galaxies shouldn't be there." Somewhere, the apple that fell on his head is rolling its eyes. The scholarly debates swarm like bees. Some physicists argue that the anomalies Webb sees may hint at modified gravity, the idea that Newton's and even Einstein's descriptions break down at cosmic scales. Maybe gravity is stronger at great distances, or maybe it has hidden components, like an encore act nobody expected. Others resist, insisting dark matter is the better explanation. Historians still argue whether to tweak the laws of gravity or keep patching them with invisible scaffolding. Either way, the debates sound less like certainty and more like cosmic couples therapy. A quirky tidbit brings a grin. One proposed modification of gravity, called MOND, Modified Newtonian Dynamics, was dreamed up in the 1980s as an alternative to dark matter. Astronomers jokingly call it moody, because it only behaves under certain conditions, like a temperamental teenager. You chuckle, picturing galaxies rolling their eyes as gravity shifts moods. Your second joke follows naturally. If gravity is moody, then no wonder the universe looks chaotic. Maybe it just had a bad morning. Someone spilled coffee on space-time and now the whole cosmos is sulking. But humour aside, the thought of gravity changing unsettles you. For centuries it's been the most dependable law. Predictable, testable, universal. If even gravity can betray you, then nothing is safe. You feel a little wobble under your feet as though the fabric beneath you isn't quite as firm as you once believed. Historians still argue whether humanity should cling to Einstein's general relativity as sacred, or accept that new physics may be looming. After all, Einstein himself replaced Newton's absolute space with curved space-time, a leap unthinkable in its day. Perhaps another leap waits now, hidden in Webb's anomalies, gravity's strange hand pulling from the shadows. Your third joke bubbles up to soften the weight. You imagine submitting a support ticket. "Dear Universe, gravity seems to be malfunctioning. Please reboot." Somewhere a cosmic technician sighs, "Have you tried turning space-time off and on again?" You drift deeper, watching galaxies bend light around them, arcs and rings warping across the field. Gravitational lensing, Einstein's great prediction, painted across the sky like melted glass. It's beautiful, yes, but also mischievous. Gravity playing tricks, disguising distances, making you doubt what's real. You wonder if it's more magician than law, pulling galaxies from its hat with a flourish. The thought lingers. Maybe gravity isn't just pulling. Maybe it's sculpting. Maybe it had a heavier hand in the early universe, pressing gas into stars, shoving matter into clusters, urging black holes to gorge themselves. If so, then the timeline isn't broken. It's just faster paced, rewritten by a force humans thought they understood but never fully grasped. A historical echo rises. Ancient philosophers like Aristotle imagined natural places, pulling objects toward Earth's centre, long before Newton formalised the force. Tonight you feel the continuity. Thousands of years of humans sensing the tug, naming it, trying to tame it. And now Webb reveals that the tug might still have surprises left. You pause to let the idea settle. Gravity, the most familiar of all forces, might be the strangest. You've never touched it directly, never seen it, only felt its effects. And if it truly has a strange hand, then the anomalies Webb finds aren't contradictions. They're messages. Messages that say, don't get comfortable. Don't assume the floor beneath you is solid. The hand that holds galaxies together might yet reveal another gesture, another rule, another dance. As your eyelids grow heavier, you let gravity's pull soothe you. Not the violent tug of black holes, but the gentle cradle that keeps planets in orbit. Moons in their dance, your body anchored to Earth. It is at once comforting and mysterious, the perfect lullaby of physics. Ahead you sense another whisper rising, not from stars or gas this time, but from something invisible entirely. Dark matter, the unseen scaffolding, hints at its presence, waiting to show you how galaxies hold themselves together against the odds. The strange hand of gravity is only part of the story. The invisible bones of the universe are next. You let gravity's tug fade into the background, but almost immediately you feel another kind of weight, not pulling you directly, but shaping everything around you. Galaxies curve where they shouldn't, clusters cling tighter than physics allows, and stars spin faster than their visible matter can explain. It's like the universe is whispering a secret in negative space. This is the presence astronomers call dark matter, the invisible scaffolding that holds the cosmos together. You can't see it, neither can Webb, but its echoes ripple through everything Webb reveals. Galaxies too massive, clusters too crowded, spirals too early. All of them seem to lean on invisible arms. You drift among those arms now, tracing curves of gravity where no light shines. The silence is eerie, like walking through the frame of a cathedral before the stones are set. A mainstream historical fact anchors you. In 1933, Swiss astronomer Fritz Zwicky studied the Coma cluster and noticed galaxies moving far too fast to be held by visible matter. He concluded there must be unseen dunkel materia, dark matter, providing the extra gravity. At the time, his colleagues mostly ignored him, dismissing his idea as eccentric. Now, nearly a century later, his hunch is woven into every cosmological model. You picture Zwicky grinning smugly across the decades, muttering, "Told you so." Here's your first joke. If dark matter is really everywhere, then technically your fridge is 85% dark matter by cosmic standards. Finally, an excuse for why there's nothing good to eat inside. The scholarly debates swirl like invisible currents. Some physicists argue dark matter is made of exotic particles, WIMPs, weakly interacting massive particles, or axions, that drift through normal matter unnoticed. Others propose stranger candidates, primordial black holes, sterile neutrinos, or something no one has named yet. And then there's the rebellious camp, suggesting maybe dark matter doesn't exist at all, that perhaps gravity itself needs modification, MOAE style. Historians still argue whether the echoes we see are proof of hidden substance or of broken equations. A quirky tidbit makes you smile. To hunt for dark matter, scientists have built detectors buried deep underground. In old mines, salt caverns, even under mountains, shielded from cosmic rays. One such detector uses a tank of liquid xenon so sensitive it can register a single photon flash. You imagine being the poor technician babysitting this ghostly aquarium whispering, "Any particles today? No? Okay. See you tomorrow." Your second joke bubbles up. If dark matter is really everywhere, maybe it's just shy. You picture it hiding behind cosmic curtains, giggling, "Oh, don't look at me." Meanwhile, scientists spend billions trying to coax it out, like parents begging a toddler to come out from under the bed. But humour doesn't erase the awe. Dark matter makes up about 85% of all matter in the universe. Everything you see, stars, planets, even your body, amounts to a cosmic afterthought, only 15% of the total. The visible universe is the frosting, the cake is invisible. You let that sink in. Most of reality is a thing you've never touched, tasted, or seen. Webb doesn't detect dark matter directly, but it maps its echoes exquisitely. Gravitational lensing reveals where the hidden mass lies, bending light into arcs and halos. Galaxies huddle along filaments of dark matter, like dew clinging to spiderwebs. You float along one of those filaments now, invisible strands stretching across billions of light years, the hidden architecture of the cosmos. Historians still argue whether this architecture is permanent or evolving. Did dark matter clump into filaments before galaxies, guiding them like tracks? Or did galaxies themselves carve the structures, dragging dark matter along? The questions hang in the void, unanswered, yet pressing. Your third joke eases the tension. You think about architects back on Earth, drawing blueprint for buildings. Then you look at dark matter and realize it's the ultimate invisible architect, designing the largest structures in the universe without leaving a single blueprint behind. Talk about working off the grid. The strangeness deepens. If dark matter is real, then it has shaped not only galaxies but history itself. Without it, stars might never have clumped, planets never formed, life never arisen. You are, in a very literal sense, a child of something invisible. Your existence depends on matter you cannot touch. That thought settles on you like a warm weight, equal parts unsettling and comforting. A historical echo joins in. Ancient mythologies often spoke of hidden realms, unseen forces guiding the visible world, spirits, gods, shadows. Perhaps unknowingly, they brushed against the same intuition, that most of reality lies beyond sight. Tonight, floating through Webb's echoes of dark matter, you feel that kinship across millennia. Humans have always suspected there was more, but what if dark matter doesn't exist? That possibility lingers too. Modified gravity theories suggest maybe the cosmos isn't hiding mass, but playing by rules we don't yet understand. If so, then Webb's data might be pointing not to missing matter, but to deeper laws of nature. You drift in suspense, caught between substance and law, ghost and equation. You breathe slowly, letting the thought expand. Either outcome, hidden matter or new physics, is astonishing. Either way, Webb's echoes remind you that most of the universe refuses to be seen, only inferred. Mystery is not an error, it is the norm. Ahead, you sense another shadow rising. Not matter this time, but energy. If dark matter is the skeleton of the cosmos, then dark energy is its heartbeat, pushing everything apart faster and faster. You ready to yourself for that revelation, knowing it will feel stranger still. You leave the invisible filaments of dark matter behind, still feeling their silent scaffolding cradling galaxies. But another force waits ahead, stranger still. Unlike dark matter, which pulls things together, this one pushes everything apart. It's not a skeleton, but a pulse, an invisible pressure inflating the universe faster and faster. Astronomers call it dark energy, and the phrase sounds less like science and more like a moody band name. You float in the widening space and it's dizzying. Galaxies don't just drift apart, they accelerate away as if some hidden hand is shoving them outward. It's counterintuitive. Gravity should slow expansion, tugging everything back toward itself. Yet the opposite happens. The universe isn't winding down, it's sprinting, picking up speed with age. You almost laugh at the absurdity. After 13.8 billion years, the cosmos has become that jogger who speeds up halfway through the marathon just to show off. A mainstream historical fact steadies you. In 1998, two independent teams studying distant supernovae discovered that the universe's expansion is accelerating. The news shocked everyone. Cosmology textbooks had to be rewritten overnight. The discovery earned a Nobel Prize in 2011. But it also left a gaping mystery. What's causing this acceleration? To this day, nobody knows. Here's your first joke. You picture those astronomers in 1998 staring at their data and muttering, well, either the universe is accelerating or our telescope is drunk. The universe, of course, wasn't tipsy. It was just rewriting the rules while humanity scrambled to keep up. Webb adds fuel to the mystery. Its precise measurements of galaxies, quasars and clusters deepen the tension between two competing numbers for the Hubble constant, the rate of ascension. Observations of the early universe, via the cosmic microwave background, and the late universe, via supernovae and galaxies, don't agree. The mismatch is called the Hubble tension, but that name feels far too polite. It's more like a cosmic tug of war, one side shouting 73, while the other insists a 7, and both glaring at each other across the lecture hall. The scholarly debates hum around you. Some scientists argue that dark energy may not be constant, it could evolve, changing strength over time like a heartbeat. Others suggest exotic new physics, scalar fields, vacuum fluctuations, hidden dimensions. And then, of course, there are those who mutter darkly that maybe Einstein's equations need tinkering yet again. Historians still argue whether this tension is a mere measurement glitch or the first crack in our understanding of space-time itself. A quirky tidbit makes you grin. One proposed explanation involves phantom energy, a hypothetical form of dark energy that grows stronger over time, eventually ripping apart galaxies, stars, planets, up to even atoms, the so-called Big Rip. Astronomers joke about it grimly as though the cosmos scheduled its own dramatic finale. You can't help but chuckle. The universe might literally ghost itself. Your second joke bubbles up. You imagine writing a breakup letter from dark energy to gravity. Dear Gravity, it's not you, it's me. I just need more space. A lot more space. Somewhere a physicist sighs at the pun. but you grin anyway. As you drift deeper, the scale of it all presses on you. Dark energy makes up nearly 70% of the universe. Let that sink in. Most of reality is this invisible push. Matter, dark and normal combined, is only 30%. Stars, planets, people, cosmic leftovers sprinkled onto a sea of expansion. You are, in the most literal sense, living on crumbs while the banquet is elsewhere. And yet Webb's precision reveals something subtler. The rate of acceleration may not be perfectly smooth. There might be fluctuations, hiccups, faint pulses. If so, dark energy is not a static backdrop but a dynamic player, drumming the beat of cosmic history. You imagine it like a DJ tweaking the tempo, galaxies dancing faster or slower depending on the vibe. Historians still argue whether this pulse is real or an artifact of measurement, so the thought that the universe could change its mind about expansion unsettles some scientists, but excites others. After all, if dark energy is dynamic, it might one day fade, or intensify into that apocalyptic big rip. Either way, your species probably won't be around to file a complaint. Your third joke slides in. If the universe is accelerating, then technically, your laundry pile is also expanding at an ever-increasing rate. Finally, an explanation for why you can never catch up. Dark energy is clearly to blame. You hover in the widening void, watching galaxies slip further apart, their light stretched into redder and redder wavelengths. It feels lonely at first, but then strangely peaceful. Expansion ensures the night sky will never collapse back into fire. It guarantees distance, space to breathe. It is both menace and mercy. A historical echo comforts you. Ancient cultures often imagined breath or spirit as the force that animates the world. In Hebrew, ruach means both wind and spirit. In Greek, pneuma does the same. Tonight, floating in the pulse of dark energy, you feel that resonance, an invisible breath filling the cosmos, expanding it with every exhale. You let your thoughts soften. Dark matter holds the universe together, dark energy pushes it apart otherwise. And you live in the fragile balance between. Too much of one, too little of the other, and galaxies would never form, or they'd rip apart before stars could shine. The fact that you exist at all feels like proof of a careful, improbable harmony. Your eyelids grow heavy as you drift with the expansion, carried on the secret pulse. Ahead you sense another shift, not in physics, but in perspective. Because sooner or later, every look outward becomes a mirror. The light Webb captures is ancient, but the questions it raises are startlingly human. You're about to face not just the cosmos, but your own fleeting reflection in it. You drift with the pulse of dark energy at your back, galaxies sliding away like lanterns released into an endless sky. But as the distances grow and the void deepens, you begin to notice something else. Every time you stare outward through Webb's golden eye, the gaze circles back, quietly, insistently to you. The universe becomes a mirror, and in its reflection you find your own smallness, your own fleeting spark. The light Webb captures has travelled for billions of years, enduring expansion, scattering the hazards of cosmic dust. And yet here it is, colliding with your retinas in this quiet moment. You're the last stop on a journey that began before Earth formed. Suddenly you're struck by the absurdity. Your body is made of the very dust Webb detects, yet you're also the observer, the audience applauding the play your atoms once performed. You're both actor and critic, star stuff turned self-aware. A mainstream historical fact roots this reflection. In 1543, Copernicus published De Revolutionibus Orbium Coelestium, displacing Earth from the cosmic centre. Humanity has been grappling with insignificance ever since. First Earth was not the centre, then the Sun was just one of many stars, then the Milky Way just one of many galaxies. Now Webb shows you universes within universes, structures so vast they make Copernicus's revolution look quaint. The humbling never stops. Here's your first joke. If humans keep losing their settled place in the cosmos, pretty soon you'll need GPS just to find where you rank. Recalculating, you're now the 7,024th most important speck of dust. But humility doesn't mean despair. If anything, the mirror Webb holds up is strangely comforting. You realise that being small doesn't mean being irrelevant. The atoms in your body trace back to early supernovae, to dust that appeared shockingly soon after the Big Bang. You're proof that the universe recycles brilliantly, that stars die so you can live, that even insignificance can bloom into consciousness. a quirky tidbit makes you smile. When astronaut Edgar Mitchell returned from Apollo 14, he described experiencing the overview effect, profound sense of unity while looking back at Earth from space. Many astronauts reported crying, meditating, or suddenly wanting to hug all of humanity. You chuckle at the thought. Webb gives you the ultimate overview effect, not of Earth, but of existence itself. You half expect to start offering hugs to galaxies. The scholarly debates hum around this mirror too. Some philosophers argue that the universe is indifferent, that human meaning is a projection on an uncaring void. Others counter that consciousness itself is the cosmos awakening to its own grandeur. Historians still argue whether humanity is an accident of chemistry or an inevitable flowering of physics. You float between those poles, finding comfort in the uncertainty. Your second joke slips in. You imagine galaxies holding their own debates. Do humans exist? One spiral asks. Don't be ridiculous, another replies. They're far too unlikely. Meanwhile, you're here, eavesdropping on their skepticism. The mirror doesn't just show smallness, it shows impermanence. Webb's galaxies blaze across billions of years, but even they will fade, colliding, merging, dimming into black dwarves. Your lifespan, decades if you're lucky, is a blink within that timeline. But rather than crushing you, the brevity makes each moment feel precious. You, fleeting as you are, get to be the witness. A historical echo comes to mind. Marcus Aurelius, the Roman emperor and Stoic philosopher, once wrote, "He who has seen the present has seen everything that has been from all eternity and everything that will be." Tonight, staring through Webb's time machine, you understand him better than ever. By witnessing these galaxies, you've touched eternity, even if only briefly. Your third joke rises gently. If life is this fleeting, you think humanity should really stop wasting so much of it waiting on hold for customer service. Time is short, galaxies are ancient, and your call is not important to the universe. But humour aside, you can't help but feel awe at the intimacy of the mirror. The light Webb reveals isn't abstract, it's personal. Those atoms built your body. That expansion carries you forward. That dust is in your lungs. The universe is not out there, it is in here. And then, a quiet realization settles on you. Perhaps this is why humans build telescopes at all. Not just to map galaxies or measure constants, but to see themselves more clearly. To confirm that their fleeting spark belongs to something larger, woven into a fabric too vast to comprehend. Webb's mirror reflects not only the universe, but your place within it. Brief, fragile and miraculous. You breathe deeply, letting the reflection sink into your bones. The galaxies blur as your eyelids grow heavy, but the mirror lingers. Ahead, you sense the story tilting toward closure. Webb is still out there, still watching, still whispering. The future stretches quietly, promising even stranger revelations. But for now, you're content to see yourself in the starlight, to feel the hum of the cosmos reflected back as a lullaby. You linger in the mirror of the cosmos, feeling the reflection fade into stillness, and slowly you begin to drift onward. Ahead lies not the past, but the future, quiet, uncertain, yet luminous with possibility. The James Webb Space Telescope is still out there, suspended at its post 1,000,000 miles from Earth, sun shields spread, mirrors gleaming, staring tirelessly into the darkness. And even as you close your eyes, it keeps watching through, promising discoveries stranger than the ones you've already seen. The galaxies you've witnessed are only the first. Webb will keep peeling back layers, mapping fainter smudges, catching even earlier photons, pushing your gaze closer to the beginning than ever before. Somewhere, perhaps just beyond its current reach, the very first stars, the elusive Population 3 giants, are waiting to be revealed. They lived fast and died young, seeding the universe with the metals that made life possible. To find them would be to see the true spark of starlight, the first flickers in the darkness. A mainstream historical fact steadies your thoughts. When the Hubble Space Telescope was launched in 1990, nobody predicted the cultural impact its images would have. The pillars of creation, the Hubble Deep Field, those photographs became icons, inspiring generations to dream. Webb, in just its first year, has already surpassed those feats. Imagine what 20 years of its golden gaze will uncover. Humanity has built a time machine that doubles as an art gallery. Here's your first joke. You picture Webb sending postcards from the edge of time. "Wish you were here," writes in photon ink, though the stamp takes 13.5 billion years to arrive. Postage delays, cosmic addition. But Webb's future isn't just about origins. It will peer into exoplanet atmospheres, sniffing out molecules like water, methane, even carbon dioxide, chemical whispers that could hint at life. It will turn its golden mirrors toward distant worlds, analysing starlight that has passed through their skies. Somewhere, perhaps, a planet is breathing, and Webb may be the first to notice. A quirky tidbit makes you smile. One of Webb's first exoplanet spectra showed evidence of clouds. Astronomers joked they'd just discovered cosmic weather reports, chance of hydrogen storms today with scattered methane. You grin, imagining aliens annoyed at the forecast. Apparently rain checks are universal. The scholarly debates about Webb's future discoveries are already buzzing. Some argue it will finally solve the Hubble tension, nailing down the expansion rate once and for all. Others think it will deepen the mystery, making the tension worse. Historians still argue whether new telescopes clarify answers or simply multiply questions. Looking at Webb, you suspect it's the latter. Each revelation so far has opened 3 more puzzles. The universe is a generous teacher, but one with a wicked sense of humour. Your second joke arrives. If Webb really does find signs of alien life, you hope the first species it spots is friendly. Otherwise, NASA's next mission might need less science gear and more diplomatic training manuals. Imagine the press release. Webb confirms methane, water, and a mild disdain for humans. But beyond humour, the sense of scale humbles you. Webb isn't just a telescope, it's a bridge. It links human curiosity to cosmic history, tying your brief lifespan to epochs that dwarf imagination. It doesn't erase your smallness, it makes that smallness feel like part of something grand. The quiet future isn't a void, it's an open horizon. A historical echo drifts in. In 1609, when Galileo first pointed his telescope skyward, he didn't know he was opening centuries of discovery. He just wanted to see a little more clearly. Webb continues that lineage, the same simple impulse carried to unimaginable heights. Humans look up, they build mirrors, and the universe answers. Your third joke settles in gently. You imagine Webb as a cosmic therapist, lying galaxies down on a couch and asking, "So, how are we feeling today?" The galaxies sigh, older than we should be, and Webb scribbles notes in infrared ink. Somewhere Freud is jealous. As you drift further into the quiet future, you realise the telescope itself won't last forever. Its fuel will run out, its instruments will fade. Decades from now, Webb will join the graveyard of silent machines orbiting the sun. But its images, its data, its stories, they'll linger. Light captured will never be uncaptured. Humanity has reached back 13.5 billion years, and nothing can erase that achievement. You close your eyes and imagine a child decades from now, looking at Webb's gallery of galaxies, just as past generations stared at Hubble's. That child won't care about debates over models or tensions in expansion rates. They'll see beauty, strangeness, possibility, and maybe, like you, they'll feel the mirror turn inward, realizing they too are made of dust, light, and wonder. The quiet future isn't quiet at all. It hums with Webb's steady gaze, with discoveries waiting like unopened gifts. And though you're drifting now towards sleep, the telescope remains awake, golden eye fixed on eternity. Your breathing slows, and the pace of the story softens. The galaxies fade into dim glows, the colours of dawn retreat into shadow, and even Webb's golden mirrors dim like lanterns at the end of a long night. The pulse of dark energy, the scaffolding of dark matter, the echoes of black holes, all of it recedes, leaving only stillness, like the hush after an orchestra lowers its instruments. You are left with a simple image, a telescope suspended in darkness, 1,000,000 miles from Earth, quiet, tireless, waiting. It doesn't rush, it doesn't grow impatient, it just listens, catching the oldest whispers the universe still carries. Every photon is welcomed, every glimmer cherished, and through it you too have listened tonight. You think of how brief your life is compared to galaxies, and yet how precious this briefness feels. You think of the mirror Webb holds up, showing you not just the cosmos, but yourself reflected in its light. Dust to stars, stars to dust, and somewhere in between, you. The future stretches ahead, wide and unknowable, but you don't need to solve it all. It is enough to have seen, enough to have wondered, enough to have drifted for a while in the company of stars. So let your eyes grow heavy, let your thoughts loosen. The universe will keep on glowing whether you're awake to watch or dreaming quietly in the dark. Webb will keep its vigil, the galaxies will keep their dance, and time will unfold in its vast, patient rhythm. For now, all that's asked of you is rest. Breathe deeply, settle in, and let yourself drift into sleep, carried by the same starlight that began its journey billions of years ago, just to find you here tonight.